Okay, welcome to this video where we're going to be doing a revise along with me the night before the exam. Now obviously I have already posted my predicted paper 3, the final video, on the channel, so if you haven't watched that already I would suggest you watch that one first, and also my previous video where I posted one question on every topic that hasn't appeared on the checklist. So they should be your priority, but if you've done both of those then you can stick around for this video and you can revise with me for these final hours before the exam. So there we go, that's the plan. Make sure you've watched those videos first, but we have a lot to get through, so we better get started.
So we've got two brackets here, it says expand and simplify. So we've got the first bracket here with the 3 at the front, and we've got the second bracket here with the 5 at the front. So I'm just going to expand them separately and see what we get. So looking at this first bracket to start with, the 3 brackets 2x plus 5. If we expand this out, so timesing both those pieces by 3 lots of the 2x gives us 6x, and 3 lots of the 5 gives us 15, and that's a plus there, so keeping the symbol the same, plus 5. Now looking at this second bracket, which we've got a 5 at the front. Now it's positive 5 at the front, plus 5, so we're going to expand them both by positive 5. So 5 times x is positive 5x, so plus 5x, and positive 5 times negative 2 is negative 10. So be very, very careful with the symbols here. That is a negative 2, so that'll make negative 10. And all we have to do is now simplify this, so tidying it up. So we have a 6x and a 5x, a plus 5x, and 6 plus 5 is 11, so we have 11x's. And we have positive 5 and negative 10, and 5 take away 10 is negative 5, so 11x minus 5, and that's your final answer, and that's it simplified. Okay, so work out the value of 2x squared minus 3x when x is negative 4. Let's see what we get here. So we have 2 lots of negative 4 squared, take away 3 lots of negative 4. Let's just work through this nice and slow. So negative 4 squared becomes 16, negative 4 times negative 4. So let's just rewrite that. We have 2 lots of 16, take away 3 lots of negative 4, and 3 lots of negative 4 is negative 12, so take away, let's just write it out slowly to start with. Let's just do 3 lots of negative 4, and now we can get rid of these brackets on this next step. So 2 lots of 16 is 32, and we're going to take away 3 lots of negative 4, which is negative 12. There we go, so we've got our double negative going on again, so that's going to be a plus. So we have 32 plus 12, and 32 plus 12 is 44. There we go, seems like a lot of steps there. Some of them you might be able to do in your head, but I think it's really important just to make sure that you keep it all really nice and clear so you don't make any mistakes when you're doing these sorts of questions. So we've got 3 brackets here, x plus 3, x plus 4 and x plus 1. Now when we're expanding a triple bracket, it's very similar to when we're expanding a double bracket in the process that I use, but it just tends to be a little bit longer, it tends to get a little bit messier, and you just got to keep it all really nice and tidy and just be careful with what you're doing. Now what we're going to do is we're just going to focus on 2 of them to start with, and it doesn't matter which 2 you pick. I tend to pick the 2 that look the hardest to expand, and for me that's going to be these first 2 here. So all I'm going to do is I'm just going to expand those 2. I'm going to forget about the x plus 1 for the moment. So I'm just going to rewrite that, x plus 3 and x plus 4. And I'm just going to expand this just like I did with my double brackets. So x times x gives us x squared, x times 4 gives us 4x, x times 3 gives us 3x, and 3 times 4 gives us 12. And again, just make sure you tidy this up now before looking at the next one. So we'll tidy those up. We get x squared plus 4x, plus 7x plus 12. There you go, once it's all tidied up. Now we've done that, we just want to reintroduce that final bracket that we had in the question there, the x plus 1. Okay, so let's stick all of this in a bracket, and we're going to times that by the x plus 1. There we go. Now at this point it does start to get a little bit messy, so make sure you've left yourself enough space. I'm just going to move this out of the way. Let's move it down here. Give ourselves a little bit more space because it does start to get a little bit messy here. So starting with the x squared piece, I'm going to times that by both the pieces in the x plus 1 bracket, then I'm going to move on to the 7x, then I'm going to move on to the 12, and I'm just going to keep it all really nice and tidy because it does get a bit messy here. So x squared times x gives us x cubed, And there we go, there's the introduction of the cubed here, which is why these are called cubics as well. X squared times 1 gives us 1x squared. I won't put the 1 in, we'll just write x squared. And then I need to move on to the 7x. Now it is going to start to get a bit messy, so I'm going to try and use different colours here just to separate it out a bit. Let's go with the green. So 7x now times x. There we go, 7x times x gives us 7x squared. It's positive, so plus 7x squared. Then we've got the 7x times the 1. One lot of 7x is just 7x. And now I'm going to move on to the 12. So moving on to that to finish it off, we've got 12 times x, which gives us 12x. And then 12 times the 1, which gives us 12. There we go. And now all we need to do is collect the like terms together. So if we have a look, we've got the x cubed at the start, that's on its own, but we've got the 2x squared pieces there and also these two x pieces here, so we just need to tidy them all up together. So 1x cubed leaves us with x cubed. We've got the 1x squared and the 7x squared, and that together makes 8x squared. We've got the 7x and the 12x, and that gives us 19x. And then the 12 at the end. And that's it, finished up, expanded, simplified. It's a little bit messy, there's a lot going on there, you do have to keep this really nice and tidy, but that is the end of that question there. Okay, so we've got larger coefficients of x here, we've got the 2x and the 3x, and I'm going to start by expanding these two. So let's write that out. We've got 2x plus 3 and 3x minus 2. So we know we're going to get the 6x squared here when we do the first two, so 2x times 3x gives us the 6x squared. And let's have a look at those middle two. So we get minus 4x plus 9x and those middle two. So minus 4 plus 9 gives us 5x. So we're going to have plus 5x, minus 4 plus 9. And then we're going to get minus 6 at the end. There we go. So just save you a little bit of time if you can do this. And let's stick that in a bracket. And we're going to multiply it by the x minus 4. There we go. We can do it all from here now. So just following the same process as before. 6x squared times x gives us 6x cubed. 6x squared times negative 4 is negative 24x squared. And then moving on to the underneath. 5x times x gives us plus 5x squared. And 5x times negative 4 gives us negative 20x. And then on to the negative 6 to finish it off. Negative 6 times x is negative 6x. And negative 6 times negative 4 is positive 24. And then we just need to tidy all this up again. So we've got the x squareds there and the x pieces here. And let's just rewrite all that nice and tidy. So 6x cubed. Negative 24 add 5 is negative 19. So negative 19x squared. Negative 20 take away 6 is negative 26. So negative 26x. And then plus 24 at the end. And there's how to do that one. So keep it all really nice and tidy, expand whichever two you want to start with, tidy it up with your third bracket at the end once it's been simplified, and then just go step by step really nice and carefully before you tidy it all up at the end. And remember what your answer should look like. You will get these cubes, the squares, the x, the numbers. Sometimes they might cancel each other out, but in none of these they have. Okay. So this is a quadratic as well, but there's no x piece in the middle. Okay, so there's no x piece in the middle, but we can find the factors of 100 and just think what they are. There's quite a lot of them. We could have 1 and 100, we could have 2 and 50, we could have 4 and 25, there's 5 and 20, and there's 10 and 10, so 10 times 10. Now because there's no piece in the middle, it means that in the brackets, and let's just write them out, the numbers that go into the brackets must have to cancel each other out to cancel out that x piece in the middle. So this has got a special one, it's called a difference of two squares, and it's because the numbers that go in there are the same, because they have to cancel each other out. So in order to get 0, if you look at all these pairings here, there's only one pair that allows you to get 0, and that is if we have 10, positive 10, and take away 10, and that gives us 0, so it's just plus 10 and minus 10. There you go, and if you expand that out, you would get x squared, you'd get minus 10x, you'd get then plus 10x, and you'd get your minus 100 at the end there. And these two pieces in the middle would cancel each other out, and we'd get x squared minus 100. So there's only so many of these questions that you can get. The little hint is this number at the end here is always going to be a square number. Okay, so if you see a square number there, you know that it's going to be one of these difference of two squares, and just double check it just to make. Okay, so this question says, Amy buys a new car for £18,000. Each year the car depreciates by 12%. How much will the car be worth at the end of 3 years? And obviously we could do this without a calculator, but we're going to have a look at doing some calculator methods here. So obviously the original value, in terms of a percentage, is 100%. Now if it loses 12%, so let's just say, okay, well we lose 12%, what percentage are we actually left with? And 100 take away 12 is 88%. Now there's actually something we can do here, because if it's going to be 88% of its value each year, there's something we can just times by straight away on the calculator, and it's the decimal version of 88%. And the decimal version of 88% is 0.88. And straight away, if we just times by 0.88, it will actually take away 12% for us. I can do that on the calculator, 18,000 times 0.88, and it gives me the answer 15,840. So that would actually just reduce it for me in the first year. And I could just do that 3 times. I could just times by 0.88 and keep on repeating that. Or I can actually do something to speed things up a little bit. And it's very similar to compound interest. And with compound interest, this is something that you add on to this multiplier here to get your 3 years. And it's a power of 3. So if I want to actually do this just 3 times very quickly on the calculator, I can do £18,000. And I can just times it by 0.88, and again I could do it 3 times, or just to speed things up a bit, you can just add a power of 3. Okay, and that will just be the same there. If it was 4 years, you'd put a power of 4, 5 years, you'd put a power of 5. Okay, and it'll just do it that many times for you. So if I type that straight into a calculator, 18,000 times 0.88 to the power of 3, and I get this answer here. I get £12,266.496. And obviously we are talking about money here, so we're going to have to round it to the nearest penny. So a final answer would be £12,266, and I'm just going to follow the normal rules of rounding, so I'll chop it off after the 9, and that rounds up to 50p there. So that 9 rounds up because of the 6, which rounds it up to 50p, so 0.50, and that'd be my final answer there. Again, just rounding to the nearest penny on any of these questions. Okay, so that's how you do it nice and easy on the calculator. Again, just thinking about the percentage, let's just pick a random one. If it depreciated by 23% each year, 100 take away 23 would leave us with 77%, and as a decimal, 77% is 0.77, so I'd times by 0.77. So just something to be thinking about there. Whatever the percentage it depreciates by, you can take that away from 100 and then convert it into your decimal that you're going to want to multiply by. So just a little bit of a quicker way that you can do this rather than having to do all those stages of each year. So this first one says a washing machine has been reduced in a sale by 20%, and then it says the sale price is £512, work out the original cost. And it's that language there that hints to us that this is a reverse percentage, working out the original cost. We're going back into the past. Now when we've got a sale price of 20%, that means something's been reduced in value. So what I do is I draw this little bar out and I think, okay, well I've got 80% and 20%. Okay, so I'm getting a little sale here, and we've got 20%. And we've got the original or the new 80% there once we've got our little sale. So what we've got to think here is it gives us this price. It says £512 is the sale price. Now this 20% here, this little bit is always going to be our little discount. Okay, so that's the amount of money that we're getting off. There we go, so that's the discount, and this is the price we pay. Okay, there we go, price we pay. And obviously when it comes to real life, unless there is an absolutely enormous discount on, it's more than likely that we're just getting the little bit there, that 20%. So what we've got to do is read the wording and see what that is. So it says the sale price is £512. So that's the amount of money we're actually going to pay. So if we're going to actually be paying £512, that's the 80%. So straight away I just write down 80% equals £512. There we go, and that's the first bit of the process here. Now all we've got to do is, the thing is, we don't actually want to know 80%, we want to know 100%. We want to know the original cost, the original 100 before that 20% was taken off there. So in order to do that, we've got to figure out what percentage can we turn this into, this 80%, so that we can turn it back into 100. Obviously there is a number that you can times 80% by, but without a calculator it's going to be really hard to work out. Now if we can get it down to 10% or 5%, that would be really useful, because we can turn that into 100% quite easily. So 80%, you've just got to think, what can you divide 80 by to get 10%? Okay, and actually we can divide 80 by 8. So we can divide that by 8, and that would give us 10%. So if we divide that by 8, we'd also have to divide this 512 by 8. Okay, whatever you do to one side, you do to the other here. So in order to divide that by 8, we're probably going to have to do some written methods. So I'm going to use a little bit of bus stop division. So 512 divided by 8, and we're going to work that out. So if we go ahead and divide that by 8, 8 doesn't go into 5, but it goes into 50 up to 48, doesn't it? So that's 6 times. It goes up to 48 with a remainder of 3 there, leaving us with 32, and 8 goes into 32 4 times. There we go, so 64. So 10% was 64 of that original cost. Now we can turn that back into 100%, because once we've got 10%, to get that back to 100, you would times by 10, and that would give us 100%. So 100% there, timesing 64 by 10, would give us £640. There we go. So our final answer there is 640. Let's have a look at another question, but before we do so, just a little note is if you did have a calculator here, once you'd identified that 80% was a 512 in this step right here, if you have a calculator, and I'll write this to the side, you could just divide by 80. So 80% on a calculator, you could do divide by 80, which would give you 1%, and then you can just times by 100. So it's a slightly different process there. It's a lot easier if you have a calculator, because once you get 1% times by 100, or just add 2 noughts on, and that'll get you to 100%. Okay, but that only works if you have a calculator there. It's probably unlikely we're going to want to do 512 divided by 80 and then times it by 100 without a calculator. Okay, so a new printer costs £288 once 20% VAT has been added on. Work out the cost of the printer before the VAT. Okay, so this is quite common type of question here, because it's obviously used in business. Businesses can claim back the VAT. So if we have a look at what we've got here, when it's an increase in value, we do have to draw these bars slightly differently, because although we've still got these two sections here, we've got the 20% being added on, but that was added on to the original 100%. So we've got 100%, the original cost, but now 20% has been added on this extra VAT. So in this question here, we've got the VAT, and that's the cost of the VAT. This is the original cost, or the cost without the VAT. And then you've got the total in this case, which is the cost plus the VAT, and that is 120%. So slightly harder when we've got an increase here, so we've got 3 to look at. Now the original costs there we're not going to be looking at, because that's actually what we're working out here. Work out the cost before VAT. So in this instance we've got either the 20% or the 120% down the bottom there once that 20% has been added on. So it says a new printer costs £288 once the VAT has been added on. So you've just got to ask yourself the question, is that the VAT that's been added on, or is that the price I'm actually going to have to pay, the 120% down here? And that actually, if you read the wording there, a new printer costs £288. It doesn't say that £288 VAT has been added on, it says that's what it costs. So that is the 120%. So I'm just going to write down that statement, 120% equals 288. Now I'm just going to take the exact same approach here. I'm going to divide this down and build it back up, but it's slightly harder here. I've got to think, what am I going to divide 120 by to get 10? And if you think, what do you times 10 by to get 120? That's 12. So in order to get down to 10, I'm going to have to divide by 12. So if we divide by 12, let's work that out, divide by 12. Not as nice when you're dividing by a double digit, but we can do that with just using a little bit of bus stop again, just being nice and careful when you do this. So we'll do this to the side. What have we got? 288 divided by 12, and let's figure that out. So 12 goes into 28 twice, up to 24, remainder 4, and then it goes into 48 4 times, so 24 there is our 10%. Okay, so 10% equals £24, and then nice and easy from there, just like the rest of these questions, we just times it by 10. So times that by 10, and that'll get us our 100%. So 100% equals, and that'll be £240, and there's our final answer there. So obviously just making sure you write that with your pound sign. That's £240 as a final answer. Okay, so in a box of cereal, 40% of the weight is nuts. The rest of the cereal is corn. Write the ratio of the weight of nuts to the weight of corn and give your answer in the form 1 to n. Now if we start by writing the ratio to start with, we've got nuts to corn, and that is 40%, and the other percent would be 60%. So that must mean we get our ratio as 40 to 60. Now this isn't too bad. To get this in the form 1 to n, then we just need to look at the number on the left and think, what do we divide that by to get it to 1? And the answer is always just to divide it by itself. So we're going to divide it by 40. And when we're simplifying a ratio, we're going to do the same to both sides. So we're going to divide the other side by 40 as well. So we already know that's going to make 40 become 1. And for the 60, you can just type that in on your calculator. So 60 divided by 40, and it comes out as 1.5. Or of course you could write that in a fractional form. You could write it as 3 over 2, but that comes out as 1 to 1.5, and that would be our final answer. And that's how you go about writing ratios in the form 1 to n. Okay, so again, there's nothing more complicated in this question. It's just there's a little bit of different wording going on. So it says Maria, Dylan and Kate share £3,000. The ratio of the amount that Maria gets to the amount that Dylan gets is in the ratio 5 to 4. And Kate gets 1.5 times the amount that Dylan gets. Work out the amount of money that Dylan gets. So we want to have a look. How are we actually going to create this ratio? Because at the moment we've got Maria, we've got Dylan and we've got Kate. But it only tells us the ratio. And that's, so let's just highlight that. Dylan and Maria, or Maria and Dylan, 5 to 4. So we've got 5 to 4 for Maria and Dylan, but we don't know how much Kate gets in terms of parts of the ratio. But it does then say Kate gets 1.5 times the amount that Dylan gets. So Dylan gets 4 parts, so if we times that by 1.5, that actually gives us a value of 6. So Kate is getting 6 parts. Remembering multiplying by 1.5, if you don't have a calculator, just adds an extra half on. Half of 4 is 2, add it on gives us 6. So now that we've multiplied that by 1.5, the rest of the question is nice and easy. Because all we're going to do now is split that £3,000 in the question in the ratio 5 to 4 to 6. So if I get rid of this little bit of working out, this times 1.5, let's have a look. In total, that ratio adds up to 15 parts. And now we know that those 15 parts equal the £3,000. So we can find the value of 1 part again by dividing by 15. And 3,000 divided by 15 gives us a value of 200. There we go. So they all get 200. So we can go about timesing them all by 200. We're actually only concerned about Dylan in this particular question. And Dylan gets these 4 parts here. So we can just answer that straight away. Dylan's 4 parts, each one of them's 200 quid. So 4 times 200 gives us £800 for Dylan. There we go, and there is our final answer. And again, you could go about obviously finding out the amount that they all get. We could do Maria times 200, which is 1,000, and Kate's times 200, which is 1,200. And you could even add them all together then and show that there's £3,000 there. But that's how we'd approach a slightly different question here. We've got to think about creating the ratio slightly ourselves. Okay, so we've got something slightly different here. It says a shop sells small chocolate bars and large chocolate bars. The small chocolate bars are sold in packs of 4 and the large chocolate bars are sold in packs of 9. The packs of small bars are sold one day to the packs of large bars sold are in the ratio 5 to 2. Let's just highlight some of the information here. We've got small, packs of 4, large, packs of 9, and then we've got small to large in the ratio 5 to 2. And then it gives us this next bit of information. It says a total of 95 chocolate bars were sold. Work out the number of small chocolate bars that are sold. So at the moment, what we've got a ratio here about the amount of packs of bars sold, and we've got the information down the bottom about the amount of bars sold. So unfortunately, we can't just split that ratio 95 there in the ratio 5 to 2. We can't just do 95 divided by 7 because that ratio there is not about the amount of chocolate bars, it's about the amount of packs that were sold. So all we want to do is turn this ratio here into an amount of what's that one there? Into amount of actual chocolate bars. So if we actually go about doing that, 5 to 2, we've got 4 in each of the small chocolate bar packs. So if we times that one by 4, that tells us how many chocolate bars are in there. So that would be 20. And in the large one, we've got packs of 9, and we've got the ratio of 2 of those. So if we times that by 9, and that gives us 18 chocolate bars. There we go. So in terms of actual chocolate bars, that ratio there is 20 chocolate bars to 18 chocolate bars. So that's the ratio we're actually looking at. We've got small to large, and it's now 20 to 18. Again, if it told us down here the amount of packs that were sold, we wouldn't actually need to do that, but because the information there says the amount of chocolate bars that were sold, we just need to change that ratio into being an actual amount of chocolate bars there, which we've done. We've changed our amount of packs into chocolate bars just by timesing that one by 4 and timesing that one by 9 for the amount of chocolate bars that are in each pack. So if we have a look now, our total for this ratio adds up to 38. So we've got 38 parts equaling 95. Now that's not very nice, because immediately in my head I'm thinking, hold on, 95 does not divide by 38. If that's 38 parts equaling 95, that is not going to fit in. But let's go with it, let's see what happens. So we've got, let's just write this to the side, we've got 38 parts equals 95 chocolate bars. So we'll divide that by 38, so we'll get 1 part. And let's just see what we get. We get 1 part equals, so 95 divided by 38 gives us a value of 2.5. And that's not very nice at all, because actually we're looking at that and thinking, hold on, we can't have 2.5 chocolate bars in each part. But let's not forget there's going to be 20 parts and there's going to be 18. So let's see what happens when we multiply these out. So if we do 20, I'm going to do this in a different colour again. Let's mix this up a little bit. There we go. So we've got 20 times by the 2.5 for the small ones. Let's just label that as small. And we'll label our large one as well. So 20 times 2.5 gives us 50. There we go, so it's gone back into a nice whole number. And also for the other one, we've got 18 times 2.5. There we go, and 18 times 2.5 gives us 45. There we go, and as you can see, they both add up to 95, don't they? And they're nice whole numbers now. Now the question obviously didn't ask us to work them both out. It said work out the number of small chocolate bars. So our number of small chocolate bars is right there, 50. So our final answer, there we are, is 50. Right, there we go. Okay, so for this question it says a train travelled from Manchester to London. Train A left Manchester at 8:35 and arrived at 11:05. So train A, 8:35 and arrived at 11:05. The train travelled at an average speed of 110 miles per hour. It says train B also left Manchester at 8:35 but was diverted by an extra 37 miles. Just highlight this one, train B also left at 8:35, diverted by an extra 37 miles, and it got to London at 11:35. Work out the difference between the average speed of train A and train B. Okay, so for this one here, we actually have 2 separate journeys. We have train A, which is going to leave Manchester to London, and there we go. If we just label that up, and we'll put the times in as well, so we can work this out. So Manchester to London, it leaves at 8:35, and it gets there at 11:05. Again, you don't necessarily have to draw these diagrams, but just to help us to visualise it. We have train B, and that is going to leave Manchester to London. The same journey, it leaves as well at 8:35, but this train arrives at 11:35, so half an hour later than train A. And there we go. So for each one of these journeys, we're going to have a look at a speed, a distance, and a time. And of course, this question wants to work out the difference between the average speeds, so we may or may not already have a speed for one of them or both of them. Of course, if we already had the speed for both of them, we could work it out straight away, so we're definitely not going to have both of them. So for this first one, train A, it leaves at 8:35 and arrives at 11:05. So that is a time of 2.5 hours. So if we keep that in hours, that would be 2.5 hours. For the next part of that, it also says it goes at an average speed of 110. So it goes at an average speed of 110, that's in miles per hour. So straight away, we're going to be able to work out a distance. Let's have a look at the second part of the journey though. This one leaves at, or the second train, this one leaves at 8:35 and gets there at 11:35. So that is a time of 3 hours. So that's going to be 3 hours, again just half an hour longer, but it is diverted by an extra 37 miles. So we'll be able to add 37 onto the distance once we know the distance of the journey. So we just need to remember that, so I'm going to underline that because we're going to start with train A. Now again, just remembering your formula for this, so every question always write it down. We're going to look at speed, distance and time. And there we go. So for the first one, we're working out a distance, so that is going to be speed times time. So we need to work out 110 times 2.5. Now again, in order to work that out, you can just do your working out to the side. So if we take the decimal out, that would be 110. We'd multiply it by 25. So 5 times 0, 5 times 1, 5 times 1. Placeholder, 2 times 0, 2 times 1, 2 times 1, and add it all together. So that'd be 0, 5, 7, 2. Hop your decimal back in, so we're hopping it back in once, so that comes out as 275. So there we go, that is a distance of 275 miles. Again, I'm going to write miles this time, because I've accidentally said meters on the question before, so we don't want to get confused between miles and meters for this. So for this one here, we'll get rid of that working out. Obviously you want to leave all your working out, but just to show you there, you can always do your working out to the side. Of course, multiplying by 2.5, you could just double it and add on a half as well, if you know some little tricks with your multiplication, but if not, just do your multiplication to the side. So that 275 miles is going to be the same as the distance over here. But of course, we have the extra 37. So we need to do 275 plus the additional 37 miles that train B was diverted, and that gives us 2, 12, 7, 10, that's 11, carry the 1, 312. So this one over here has had to go 312 miles. And there we go. Now we can go about working out the speed for this journey. So for this one here, to get speed, we're going to do distance divided by time. So we need to do 312 divided by 3. And again, we can just do that to the side using some working out. So 312 divided by 3. 3 goes into 3 once, doesn't go into 1. Carry the 1, it goes into 12 4 times. So the speed over here is 104. And again, that's in miles per hour. So there we go, we have our two speeds. We had 110 from the question, 104 from what we've just worked out, and it wants us to work out the difference in the speeds. So in order to get the difference, our last little bit of working out, and you can do this in your head, but obviously we'll show our working out for this, it would be 110, take away 104, and when we do that, you just get the answer 6, and that is 6 miles per hour. And there we go, that's our final answer, and that is the difference between their speeds. Okay, so this question says Harry travels from A to B at an average speed of 50, and then he travels from B to C at an average speed of 70. Harry takes a total of 5 hours to travel from A to C, and the distance from B to C is 210. Calculate Harry's average speed. Right, so let's have a look at this one then. So we've got A to B, and we've got B to C, and then we've got the total overall journey there. There we are. And thinking about what we've got a speed, distance and a time, and we'll see what happens in this question. So in this question here, let's have a look. We've got an average speed of 50 for the first one, an average speed of 70 for the next one, and then we've got a total time of 5 hours from A to C. So this time we've been given our total. Look, we've got 5 hours as our total, and we've got the distance from B to C, which is 210. There we go, so 210. Right, so let's have a look at how we can now go about working this one out then. So ultimately we are looking for the average speed for the total journey. So we're looking for this one here, but we're missing quite a lot of pieces. Now what we can do is we can start to work backwards. So if we have a look at this first section here, this second journey from B to C, from Brockley to Cantham, if we can go about working that out, we can get this time down below, and we can definitely do that. Speed is distance over time. So time down the bottom for this first little box that we can work out here is distance divided by speed. So 210 divided by the speed, which is 70, and that gives us 3 hours for that part of the journey. Now we can work backwards because we know that these two journeys have to add together to make 5. So the other part of the journey, if we do 5 take away 3, tells us that this first part of the journey must have been 2 hours. And now we've got that, we can work out the distance of that journey. Distance is speed times time. So this one here, speed is 50 and the time is 2, so that must have been 100 miles. There we go, and now we can get our total distance for that journey there. So we've got 100 plus 210, and that equals 310. And now we can just finish it off like a normal question. So it's not particularly any more difficult than the previous questions. It's just actually working backwards to go back to that first part of the journey so that we could get the overall distance for this total journey here. So now we can do our normal sum. We've got distance divided by time, so we've got 310 the total distance divided by the 5 hours, and 310 divided by 5 is 62 miles per hour. There we go. And also thinking about the logic here, that is in between 50 and 70, so our answer makes sense. And you should always be thinking about that. Does my answer make sense? Is it somewhere in the middle of the two? Now it says here that angle or A, B and C are points on the circle of radius 5 centimeters, centre 0. So we can see that on the diagram. We've got the radius drawn in there and it's been labelled with that 5 centimeters. And we are going to be looking for the length of an arc in this question. So let's just have a look and read through the rest of it. It says DA and DC are tangents. So we've got these two lengths here that are tangents. So we've got these tangent questions being sort of in a lot of these sort of exam questions, so it's definitely a very important one for us to know. And we have DO is 9 centimetres. Now that length there is not on the diagram, so we need to label that on straight away. As soon as we read that information and we see it's not on the diagram, we'll label that on. So that's length here, 9 centimetres. It says work out the length of the arc ABC, and ABC is the big one here around the outside. And in order to work out the length of that arc, we're going to need to know the angle of that major sector there. So we need to get that angle around the outside. Once we've done that, we can use our circumference formula or arc length formula in order to get that arc length. But let's have a look. So what can we work out? Now, we already mentioned that there's some tangents. So we know that this is a right angle and this is a right angle as well. And what we need, in order to get that angle out the outside, we need these angles just here. Okay, so there's two of them. Now that quadrilateral there is split perfectly in half, okay, to form two right angled triangles. And those two right angled triangles are congruent, so they are exactly the same there. The tangents meet at equal length. They're both 5 centimetres as the radius, and they both share that 9 centimetre line. So these are two congruent triangles. So if we find the angle in one of those, we can double it up and then find the angle around the outside. So that's how we're going to approach this question. Now, in order to find that angle there within a right angled triangle, we are going to be using a different topic. So we're going to be using SOHCAHTOA. So in order to find that angle there, if we think about this, we have got, and if I draw this triangle, maybe let's draw it down here. We've got a right angled triangle. We're trying to find this angle here. We have that the hypotenuse is 9 centimetres and the adjacent side to the angle there is 5 centimetres. And again, just doing a bit of SOHCAHTOA, so label it up. You've got your hypotenuse and you've got your adjacent. So we're going to be using cos. So cos, or if you use a formula triangle, CAH, and we're going to be working out the angle. So we need to do cos minus 1, A over H, which is 5 over 9. So again, let's type that into our calculator. Cos minus 1 and then 5 over 9, pressing equals, and we get our angle there, which is 56.251 0.114. So that is that angle just here in the centre. Now obviously we've got two of those, so we need to double that to get the full angle. So let's just get rid of this. So this full angle here is going to be 2 lots of the 56.25. So 2 times, that's not a 5, let's do that again. 2 times 56.2510114. So times by 2 on the calculator, and we get 112.502 and 0.228. Now notice that I am leaving all of the numbers there when I write it down. It's asked me in the question to give my final answer 3 significant figures, so I don't want to get any rounding errors along the way. So unless it's going off the screen on the calculator, I will always write it up to at least 7 decimal places. Now this one doesn't actually stop at 7 decimal places, but we'll leave it there just to make sure it's as accurate as possible. Now we can go about working this angle here. Again, angles around a point add up to 360. So if we do 360 and we take away this 112.502 number, I'm not going to write them all down there because I'm typing this in on the calculator, 360, take away answer, and it gives us a final angle there of 247.4979772. There we go, degrees. So that's our angle there in the major sector. Now we need to find the length of the arc. So we need to know our formula for working out arc length. So another topic that's involved in here. So we have pi times by the diameter, or times by 2r, whichever formula you use, times by the angle, which I'm going to call theta, over 360. So if we plug all these numbers in, we have pi times the diameter, which is 2 of those 5s, so times 10, times by this angle over 360, so 247.49, and the rest of those numbers all over 360. So again, I'm going to use the answer button on my calculator. So leaving that answer there, pi times 10 times, pressing my fraction button, answer over 360, and it gives us an answer here which comes out as 21.59827,297. And again, then referring back to the question, it wants it to 3 significant figures, so that's going to be 21 point, the third significant figure is the 5, it's a 9 afterwards, so that's going to go up to 21.6, and the units are centimetres, so we get 21.6 centimetres for this question. So there we go, you can obviously see how that one's a lot trickier. It doesn't actually involve that many circle theorems. It obviously involves the tangent to the radius being 90 degrees, and it involved knowing that 2 tangents meet at equal length. But other than that, it didn't involve too much in terms of the circle theorems, but it was using circle theorems to solve a much harder problem. Okay, so this question says work out the length of BC. Let's just identify that there. So the length BC is this length across here. And it says give your answer to correct to 3 significant figures. Now straight away it doesn't actually stand out that you definitely need to use Pythagoras for this, but we are working out lengths, and Pythagoras is one of the skills we have to work out lengths in different shapes. Obviously only when it comes to right angled triangles, but different shapes, if we can find a right angled triangle somewhere, we can apply Pythagoras to help us work it out. And in this type of question, look, if I chop from the D down to the base, that creates a right angled triangle here on the right, and we have a rectangle on the left. Now because it's a rectangle on the left, we can say that the 2.1 there is the same as the 2.1 down here, and that's in metres, and the 1.9 there is the same as the 1.9 over here. Now that means that we've got enough lengths in this right angled triangle now, we've got the 3.2 and the 1.9 to work out the lengths down the bottom here, which I'll put a little X next to. And then once we've got that, we can combine it with the 2.1. So looking at that right angled triangle we've got the hypotenuse look opposite our right angle, so we're going to do square square and then minus and then root. So 3.2 squared, take away 1.9 squared, we'll work that out and then root the answer. So on the calculator, 3.2 squared, take away 1.9 squared, and that equals 6.63. There we go, 6.63. So square rooting that, so 6.63, the square root of that, and that equals, let's have a look, 2.5748. 2.5748 and a few more decimals. Now again, it says it wants our answer correct to 3 significant figures. Obviously just make sure you read that. So if we round this to 3 significant figures, we get 2.57. There we go. And this is in metres this time, so 2.57 metres, and I can label that down here, 2.57 metres. Now I can work out the full length of BC there, because we've got the 2.1 and the 2.57, and if we add those together, 2.1 plus 2.57 comes out as 4.67. So let's just write the working out for that down up here. 2.1 add 2.57. I should probably tidy that up with a 0, and that comes out as 7, 6 and 4. So 4.67 metres, and there is our final answer for that question. Now obviously when you're looking at 3D trigonometry, it is going to be very important that you are pretty comfortable using SOHCAHTOA, and then pretty comfortable as well using the sine or cosine rule if they do crop up, which they may well do in some of these questions. So do make sure that you're pretty clued up on those topics first. Again, they're going to be linked in the description below in the trigonometry series, so do check those out. But we're going to get started and run through some of these questions. So this first one here, it asks us to find, and let's just have a look at the information in the question. And one thing I'm going to do on these is that I've not really looked at these questions in depth. I've seen them in the past, but I'm just sort of going to run through them as I would sort of approach them if I was to be sort of sitting these in an exam. So let's have a look and read the question. So we've got a cuboid, and it's quite nice, this one. It's drawn some lines in for us. It's going to help us along the way. Again, we'll discuss that as we go, but it says here we've got angle EDH is 64. So we need to label that on. So let's find EDH. So E to D to H is this one down here on the base. So on the base there, that is 64. Can just about fit that in. Then we've got the next one. ACD is 28. So angle A to C to D, and that's over there on the back face. There you go, just back there, and that's 28. Right, there we go. And then we've also got the E to H is 15, which is given to us on the diagram, but that is also going to be the same as the one back here. and also the ones on the top there, but I'm going to minimise the amount of labelling that I do. So I'll put 15 back there because I'm assuming that I'm probably going to need to know that. And it says work out the size of angle. I'm going to do this in a different colour. Angle AHD is what we're looking for. So A to H to D is on this inner triangle there, and that's what we're trying to work out. So I'm just going to put a little X in there just so I remember what I'm actually looking for. So looking at that triangle on the inside, we've got AHD, that triangle. If I draw that over here, and this is the little trick with 3D trigonometry, always to redraw these triangles to the side and sort of take it away from the 3D picture. But I'll label all the corners so you know which one I'm looking at, A, H, and D. Okay, and at the moment, we are looking for this angle here, and we don't have any of the other side lengths involved with that triangle. Now there's a couple that we can probably find. I'm just thinking on the back triangle, so on this back one here, there we go, I'll label that up. We've got one of the angles and a side length. So if we go about using SOHCAHTOA, we can work out the length of A to D, which is going to be this length here. And once we've got that, that'll be one of our pieces towards that triangle there, because obviously we can find that angle as long as we've got two sides using SOHCAHTOA. So I'm going to start with that one over there. That's going to be the first one that I'm going to find, and that's going to give me one of the two pieces that I'm going to look for. And we'll have a look at what other piece maybe we can find afterwards. But let's look at that back triangle to start with. So again, I'm going to draw this to the side. We've got a right angled triangle, let's C there, D here, and A at the top there. There we go, and we've got this angle here being 28, and we've got the bottom there which is 15. So I'm going to work out this one here, the side that's opposite the angle there. So using SOHCAHTOA, we've got the opposite, remember to label it up, we've got the opposite, and this is the adjacent. So there we go, we're going to use tan for opposite and adjacent, and we're working out the opposite, so that is going to be a multiplication there. We're going to do 15 multiplied by tan 28, and that's going to tell us the length there. And again, obviously those of you that like to use formula triangles, there you go, TOA, we're looking for the opposite, so it's a multiplication. So 15 tan 28, and all these are going to be on the calculator, so I'm going to be doing this on the calculator. So we've got 15 tan 28, and that gives me an answer here of 7.975. Now the final answer, look down the bottom, wants it all to one decimal place. So I'm going to leave all my answers to about 3 decimal places. So we'll be rounding them to 3 decimal places as I go, rather than writing all the working out down. But 7.976 if I round it to 3 decimal places. There we go. It's 5.6 there, so that rounds up to 976. Right, so that's that length. Let's label that on the diagram. 7.976 just there. And we can also label that on our final triangle up here, which is 7.976. There we go. So we need one more piece. Now, let's swap to a different colour to look at this next one. Now, we've been given that angle 64 on the bottom. So if we have a look, and this is the triangle, I'm going to swap to a different highlighter here. I'm now looking at this triangle that's on the base, which is a right angled triangle, as we've got that angle there in the corner, right in the bottom left corner of the cuboid. So I'm going to redraw that triangle separately, and I should be able to get this length here, and that's going to be this length here on our final triangle. And once I've got that, we'll be able to finish this question off. But let's draw this triangle on the base. So on the base there, if I draw the base out, again, I could draw it as a rectangle. You could draw this line in if you want, but I'm just going to remove that. I'm just going to look at the actual right angle triangle. So we've got 64 up here. There we go. We've got 15 centimeters again down here, and we're looking for this length here. So that is D, E, and H. It meets that down there. Right, there we go. So that's enough information there for us to actually work out the length of X. So if I label this up using SOHCAHTOA again, so we've got the opposite, and we're looking this time for the hypotenuse. So we're going to use sine, and again, if you want to write down your formula triangle, SOH, we're looking for H. So we're going to do a divide. So we've got 15 divided by sine 64. There you go, 15 divided by sine 64. And let's just work that out on the calculator. So 15 over sine 64. And that gives us 16.689. Okay, so 16.689. There we go, and let's label that on the diagram. 16.689. There we go. And we can then label that obviously on our triangle over there on the left. So now we've got 16.689 for the bottom there. And now we can actually finish the question off. Now we've got that triangle on the left there. We've got all the side lengths we need, or 2 of them at least, so we can find the length, the size of the angle. So opposite that angle, there we go, we've got that, the opposite, and we've got the adjacent down here. So again, we're going to use tan just like we did in the first triangle, but we're going to be finding an angle this time. So remember, just keep writing down all your formula triangles if you use them. We're looking for tan, so the t part, the angle, so we're going to do tan minus 1, so shift tan, just to make sure we tell the calculator we're looking for an angle, and when it's opposite over adjacent, so it's 7.976 all over 16.689, and then close your bracket. Right, let's type that in on the calculator. So shift tan, fraction, 7.976, and then on the bottom 16.689. Come out of the fraction and close the bracket there. Press equals. There we go, and we get an answer. We get 25.544. A few more decimals, but I'll leave it to 3 decimal places for the purpose of the working. And then it wants it to 1 decimal place, so we chop it after the 5. There we go, and we get 25.5 degrees. There we go, and there's our final answer for this first question. Let's just highlight that up. There we go, and there's our final answer. Right, so there's the first one. I do think that was a relatively nice one because it gave you those little diagonals drawn in, and a lot of the time you're going to have to draw them in yourself or visualise them yourself. But hopefully you see the little tips here that I'm sort of doing. I'm drawing these right angle triangles separate to the 3D shape, just to help me sort of visualise it a little bit better rather than drawing all over that shape and making it a complete mess. Okay, so a slightly different question here. We've got some negatives in our vectors. We've got a negative on the top of A and a negative on the bottom of B. So that indicates a left movement of 2 there for vector A and a down movement of 1 for vector B. And it wants us here to write down 2A minus B as a vector. So we're going to do the vector 2A. So let's do that one to start with. We've got 2 lots of, and then we have minus 2 and 5. And we're going to take away from that vector B, which is 3 and minus 1. Okay, let's sort out this 2 lots of vector A to start with. So doubling both of those, we have minus 4 over 10. Okay, so just doubling those, and we're going to take away this 3 over minus 1. Now we're going to deal with the top numbers to start with. So let's just think about this numerically. We've got minus 4, and we're going to take away this time, we're going to take away 3. So minus 4, take away 3, leaves us with minus 7. And on the bottom there, we just need to be careful because we're going to be doing 10, and we're going to take away that negative 1 on the bottom. So taking away a negative, that's obviously going to add 1. So actually we're going to do 10 add 1 here, and that's going to be 11. And there we go, there is our final vector, minus 7 over 11, written as a column vector. Okay, so for these next few questions, we've got some visual vectors that we can actually see drawn on a grid. And it says in the question here, the vector A and B are shown on the grid. And we've got vector A that we can see there going sort of upwards to the right, and vector B that we've got going downwards to the right as well. And it says for part A here, on the grid, draw and label the vector minus 2A. Now obviously 2A will just be double the distance of A. The fact that it's put a minus in there means it's going in the opposite direction. So instead of our arrow pointing upwards, it's going to be kind of coming downwards to the left. So in terms of looking at this, we just need to establish what the pattern is of A, just to make sure that we draw this in correctly. And you can kind of see if we start from a certain point, we need to go across 1 and we go up 2. There we go, let's draw that again. So we go across 1 and we go up 2. Right, so in terms of actually getting the pattern here, we just need to pick somewhere, hopefully not somewhere where it's going to overlap with A. So let's start down here. There we go. And we're going to go across 1 up 2, which gets us to there, across 1 up 2 again, and that will get us to there. Okay, so let's rub that out. So in terms of actually drawing the line in, that would be the vector 2A, double the distance of A and following that same pattern across 1 up 2. The fact that we're doing minus 2A just means we need to point the arrow in the opposite direction. So there we go, we can label that. That would be the vector minus 2A. And there we go, there's part A done for that one. Now for the other one, we've got to work out the vector A plus 2B as a column vector. And the process of looking at the pattern is really going to help us for this. So we looked at the vector A to start with. Now that vector A, and we can write this down over here, the vector A, it went across 1 and up 2. So that would be 1 in the positive right direction, and then 2, obviously being a positive in the moving upwards. So there's our vector A, 1 over 2. Now the vector B, let's have a look at that one. So from the start, obviously it's going downwards, this one, as shown by the arrow. That's going to go across 1, so a positive 1, and then it goes down by 3, so that'll be negative 3. So the vector B, if we write that in, B is equal to 1 over minus 3. So now we've established that, we can just treat that like we did in those earlier questions. We're going to do an A, and we're going to add to that 2 B's. So in terms of writing this one out, we've got A, which is 1 over 2, and we're going to add to that 2 of the B's. So that's going to be 2 lots of 1 on the top, which is 2, and 2 lots of minus 3 on the bottom, which is minus 6. There we go, we can add those together, so 1 plus 2 on the top gives us 3, and then 2 add negative 6 on the bottom. Well, when we add negative, that's going to take that away, so that'll be minus 4 on the bottom. So our final vector will be 3 over negative 4. And there we go, that's how we're going to approach these vectors when they're on a graph. Obviously we can just turn the vector into a column vector and treat it just like we did on the previous questions. With a dependent event, it means that the second event that we're looking at is going to be dependent on what happens in the first event. So different to the first video on this, on independent events where nothing seems to change, in this type of question something is going to change on that second event, and we're going to have a look at what that second event is based on the question. Now, there's loads of different types of questions that you can have on this, and this is purely sort of looking at these particular type of questions, but there are certain other questions that we could have as well, and I may have a look at some different ones in a few different videos, but I'm going to focus on these as they seem to be the ones that people struggle with the most, where we've got counters and they're not being replaced, and we're going to discuss the language just there as we get to it. So this one says James has a bag of counters. It says in the bag there are 5 red counters and 3 blue counters. James takes at random a counter from the bag and notes its colour. He does not put the counter back in the bag, and I just want to emphasise that he does not put the counter back in the bag, because that there is what tells us this is a dependent event, okay? And we'll have a look at how it affects it a little bit later on as we get there. It says he then takes at random a second counter and work out the probability that James takes 2 different coloured counters. And again, obviously we need to be careful with the language there for that last little bit. James takes 2 different coloured counters, so I'm just going to highlight that as well. Okay, obviously do check out the previous video. We discussed a little bit more of the language and on actually working out the probability roots in that. I'm going to assume that we're a little bit more clued up on the actual question there from the previous video. So he does not put a counter back in the bag. Let's have a look then. So the first pick that he's going to take out, he has a red or a blue as his options. Okay, so there are 5 red and 3 blue, and if we add those together again, 5 plus 3 equals 8, so it's out of 8 counters. So we have 5 that are red out of 8 and 3 that are blue, and again that's out of 8, and this is going to represent the first pick, which I'm just going to highlight as there as being the first. Now we have 2 different options here. I'm going to draw a little picture. Now if I just imagine we've got 5 reds, so 1, 2, 3, 4 and 5, and there are then 3 blue. Let's colour that in as well, so 1, 2, 3. Now obviously we have this little option here. Let's just draw this little picture like I've done before. So we have a little option, we've got a little person at the front, my amazing little drawing here, there we go. So we've got a little person, he goes up the red route and he ends up here. Okay, now what is this option for the second pick now the counter's not replaced? Now if I just cross one of them out, let's have a look, let's get rid of this red one here. So that red one's gone. Now what is the probability of taking a red or a blue? Well, clearly one of the counters is gone, so it's definitely going to be out of 7. So let's just have a look at the 2 options that we have on this part of the tree. So the second option. Now it's out of 7 because one of the counters is gone, so we can put both of these are going to be out of 7. Let's make sure we label it red and blue. And if we have a look over here at the diagram, look, there are 4 red counters left, so it's going to be 4 reds. And that would make sense if he takes out a red, that red would go from 5 down to 4. And obviously a blue hasn't been taken out, and you can see, obviously there's still 3 blues here, so it's going to be 3 blues. Obviously those numerators have to add up to 7, and 4 and 3 do, they add up to 7, so that's absolutely fine. Now let's just restart. So we've figured out that part of the tree if he takes a red, so let's go back to the start of this little story here. We'll get rid of all of this, and we'll imagine now that instead we've taken out a blue. So let's cross out a blue, blue's gone, and now we're down here on this part of the tree figuring out what we're going to take on this next one. So what are our 2 probabilities? Now this time again, let's label it all up, red and blue. This part of the tree is not going to be the same, so different to some of those independent events, this part of the tree is going to change. Now if a blue's gone, having a look at our diagram now, we've still got 5 reds. So we've got 5, again out of 7 because one of them's gone, but now we've only got 2 blues because one of those blues is gone. That would make sense that the blues would drop down from 3 to 2. So that's going to be 2 out of 7. There we go. And that is our tree there constructed, and now we can use that to work out our probabilities. Let's just get rid of all these little drawings that I've done with my little people. There we go. Right. Let's get rid of that and put that back in. Now you don't have to use this little diagram, this little visual idea of the counters, but if you do struggle with these, it can just be a helpful way just to visualise it. But I'm going to get rid of those now because we're going to do the maths behind it. Now, looking at the roots, it says 2 different colours. So we have 2 options again there. We could have a red and then a blue. and that goes through 5/8 and 3/7. So again, we're going to multiply those together. So 5/8 multiplied by 3/7 gives us 15 on the top and 56 on the bottom, 8 times 7. Then we also have another route that we can go through. So if I swap colours for that, we could have a blue, and then we could have a red, and again that's going to be the 3/8 there multiplied by the 5/7 on that second branch, and that again gives us 15, and it again gives us out of 56 there. So there's our two probabilities. Obviously, when we've got two that we need to combine for these different colours, we're going to add those two together. So just make sure that you add those two together carefully, write your working out down. So 15 over 56, add another 15 over 56, and in total that gives us 30 on the top out of 56, and there is our total probability of getting different colours there. 30 different options of doing that out of a total or potential 56 different ways of picking these counters out. So 24, if I do that as a product of prime factors, I'm going to do these quite quickly. We get 2 and 12, 2 and 6, and then 2 and 3. Okay, and again we circle all our prime numbers there. 108 is a product of prime factors, not quite as nice, but if we halve it we get 54, so 54 and 2, half of 54 is 27 and 2, 27 is 3 times 9, and 9 is 3 times 3. So we've got our product of prime factors there, circling all the prime numbers. Now if we write out both our lists, let's have a look. So 24, we've got 3 2s and a 3, so 2 times 2 times 2 times 3. 108 is slightly longer, let's have a look. We've got 2 2s and 3 3s. So 2 times 2 times, how many was it? And then 3 times 3 times 3. Now to get the highest common factor, all I'm going to do is I'm going to have a look at what's in both of them. So in both of these lists here, they both have a 2. They also both have another 2, so they have 2 2s each. And then the top number, the 2 times 2 times 3, there's a 3 in there, and there's also a 3 in the bottom. So in both those lists, we have 2 times 2 times 3. And if we multiply those numbers together, 2 times 2 times 3, just in one of the lists, not all 6 numbers, just these 3, we'll get our highest common factor. 2 times 2 is 4, times 3 is 12. So our highest common factor there is 12. Okay, so it does take a little bit longer, but it does help just to avoid missing any of those factors that we might have done when we were writing a list. So pens come in packs of 8 and pencils come in packs of 20. If we want to buy the same amount of pens and pencils, how many packs of each do we need to buy? So again, we've got pencils come in 20 and pens come in packs of 8. So if we find the lowest common multiple of these and see what we get. So for 8, for the pens, let's label this pens and pencils. And pencils comes in packs of 20. Okay, so 8, 16, 24, not 36, 32, sorry, 40, 48 and so on, but actually I've just spotted there that 40 is going to be our next one in the pencils. So we're going to have a look. 40 is our lowest common multiple, but the question said, I'm just going to highlight this, how many packs of each do we need to buy? So having a look at this, the pencils, that's on the second pack, isn't it? So 2 packs of pencils. And if we count along on the pens, we've got 1, 2, 3, 4, 5. So 5 packs of pencils. There we go. Now to be fair, with this question it said how many packs of each do we need to buy if we want to get the same amount. Now you could have kept on going actually. If we keep going on the pens we'll get to 80. If we keep going on the pencils we'll get to 80. So we could buy double each. We could buy 4 packs of pencils and 10, sorry, I've written pencils for both of them, haven't I? That should say pens. There we go, so 5 packs of pens. So what we could actually do is double both of them. We could buy 4 packs of pencils and 10 packs of pens. And that would still give us the same amount for both. So we're just going to find the smallest one because it doesn't say, but we could have actually kept on going. It'd be a bit silly for us to keep going when we've already found one that gives us the same amount, but there we go. Okay, so this question doesn't actually have the word truncated in there. And if we have a look at this, it says James completes a maths question on his calculator. He writes down the first 3 digits on his calculator screen, and the answer that he writes down is 24.8. Write down the error interval for his answer. So obviously it doesn't mention anything about rounding. It doesn't say he's rounded it to 24.8. 24.8. So therefore we know it's not about bounds, it's not about rounding with error intervals. This is about truncating, because all he's actually done is written down the first 3 digits. And remembering that the 4th digit there could have been a 9, in which case it would have rounded to 24.9. Okay, but obviously it just says here, he wrote down the first 3 digits. So this is about truncation. We'll spot that in the language. This is why this sort of question is worth writing down here for your notes. So that's the number we're dealing with. I'm not going to treat it any differently. I'm just going to put 24.8, which is the smallest it could have been. And then the next number above that will be 24.9, following that pattern from the previous ones. It has to be somewhere between 24.8 and 24.9. And there we go. That's how you obviously can spot in a question that it's actually talking about truncation, not about rounding.
Okay, so when ordering recurring decimals and also just normal decimals, we want to just add a few extra decimal places so that we can see exactly what they look like. Now all of these in the first 2 decimal places have a 1 and a 3. So if we go to 3 or 4 decimal places, and we'll think about ordering them from there. So for the first one, 0.13, that would be 0.13 and then 2 zeros after it. For the next one, I'm just going to put a comma in between to separate them. That would be 0.13 and it's recurring 3s, so it'd be 2 more 3s. For the next one, we'd have 0.131 and it's a recurring pattern of 1s and 3s. So the next 2 numbers would be another 1 and then a 3. If we keep it consistent, then we would want to get rid of that final 3 there, so it's just those 4 decimal places. For the next one, it goes 0.131 and then it's a recurring 1, so that's looking the same as that 3rd decimal, so we're going to have to come back to that. And for the final one, it's 0.13 and it's recurring patterns of 1 and 3, so 0.1313. Now obviously these 2 in the middle here at the moment are identical, but they do have different numbers in that 5th decimal place. So if we write that in, so for that 3rd one there, it was a recurring pattern of 131. So after that 1 that we wrote, it would be a 3. And then for the next one, it was a recurring pattern of 1s. So after that 1, there would be another 1. So that's going to help us just to order those 2. So the smallest, as we start to put them in order, you can see that this one here, our 0.13, is our smallest decimal. So we'll put 0.13 and that's the first one. Now after that, none of them have a 0 in that 3rd decimal place, but we do have a few that have a 1 in that 3rd decimal place. We have those final 3. So just looking at these 3 here, they've all got a 1 in the 3rd decimal place. So we're going to have to look at that 4th decimal place, and as you can see, the 2 that we looked at in the middle there both have a 1 in the 4th decimal place, whereas the 3rd one here has a 3 in the 3rd decimal place, so that's going to go last. So to put this in order, that one that has a 1 at the very end, that's going to be next. So that was our 4th decimal. So that's 0.131 recurring. The next one is the one with the 3 at the very end. So that's going to be 0.131, where there's a recurring 131. And then our final one is this one at the end, where the 3 is in the 4th decimal place. So 0.13, and then both of those are recurring. And then our final decimal, the only one we haven't used yet, is this one here in the 2nd position, and that was 0.13 with a recurring 3. And there we go, they are in order. That would be our final answer, and we'll just highlight that. And there we go. That's not very nice there because there were 5 recurring decimals. It'd be more likely that you'd have 4, but not to say that you couldn't have 5 if you were going to arrange something like this. And the real nasty part with this question was these 2 just here, where we had to go right up to the 5th decimal place to see which one was bigger or smaller.
Okay, so for this question here, it says sketch the graph of y equals 12 minus x squared, showing any points of intersection with the coordinate axes. Now there's one point of intersection we can get straight away, and that's that number at the end. Well, in this case it's at the start, but normally it's at the end when we have a positive quadratic. So that number 12 there, that's our y-intercept. So if we label that straight away, obviously we're not going to forget then, and then we can label that as later on when we actually draw this. Not forgetting as well, it's a negative quadratic, so it is going to be sloping this way, even though we are going to change it to a positive quadratic for the purpose of solving it. So when we go about solving it now, let's have a look. Now again, I am doing a little bit of, I don't want to say a trick, but I am just going to, when I factorise this -1 out, I'm not actually going to write that factor of -1. As I'm going about this in order to solve it, I don't really need to write that. But if I take that -1 out, we get positive x squared, the negative x there is going to turn into a positive x, and the positive 12 is going to turn into a negative 12. And I'm going to factorise it from there. So again, using that same process as before, we can have 1 and 12, we could have 2 and 6, or we could have 3 and 4. And we're trying to make positive 1 in the middle, so that's going to be 3 and 4. So we're going to have positive 4, take away 3, and that would give us positive 1 in the middle. Not forgetting that when it is just an x on its own, that is 1x. So in our brackets here, we've got x plus 4, and we've got x minus 3. There we go. And as we're solving it, let's set it equal to 0. There we go. Now obviously, as I said before, we do need to swap these numbers around. Now the first one doesn't matter, so we can keep that as x plus 4, but we should really swap these other ones around. So when it's factorised, it would be 3 minus x rather than x minus 3. There we go. But we can still get our two solutions from the starting brackets, remembering that you can just set the bracket equal to 0. So when this first bracket equals 0, x equals minus 4, and when this second bracket equals 0, you would get 3 minus x equals 0, add the x over, and you get x equals 3, just as we would from that first bracket there, just flipping that minus 3 sign over. So we get x equals 3. Okay, so let's get rid of that. We need to actually go about drawing this now. So if I draw just a basic sketch, as it does only say to sketch it, we just need to take into account for the fact that the two solutions, one of them is negative and one of them is positive, and then obviously we have that y-intercept at 12. So I'm going to need to draw the positive and the negative part of the x-axis. We're going to want to go through minus 4 and 3. Don't have to worry too much about the scale here. Obviously 12 would be a lot higher if we had you know, the same scale on either one, but I need my negative quadratic to go up through the y-axis, back down. I just need to label all those points where it intersects the axes. So it goes through here on the y-axis at 12, it comes through minus 4 on the x-axis, and it goes through 3 on the positive part there. So there we go, that's how we would sketch a negative quadratic. Obviously it does say any points of intersection with the coordinate axes, so that includes the x and the y axes, so that's why we've got the y-intercept on there. And obviously that process to find where it crosses over the x-axis is to solve it. So just remember, change all the signs, factorise it, and then swap the pieces over in the bracket. Although if there is a plus sign in there like this x plus 4 one, then it's just going to remain unchanged, but you could write 4 plus x if you want. We've got some square roots introduced in this one. Now when we've got a square root here, everything underneath it is completely locked until we get rid of this square root. Now the opposite, the way to get rid of a square root is just to square both sides. So if we square both sides, we'll get y squared on the left, and squaring the right hand side literally just removes that square root, so nothing's going to change underneath it. We just have 3x plus 4. So once we've done that quite nice and easy, it looks quite similar to some of the others. We're going to minus 4 from both sides. Then we get y squared minus 4 equals 3x. And then finishing it off just like some of the first ones we did, we're going to divide by 3. So divide by 3, and we get y squared minus 4 all over 3 equals x, or we could just write the x equals at the start. So x equals y squared minus 4 over 3, and that's our final answer there. Just remember that when we've got the square root, everything's locked in until we square both sides. Okay, so a slightly different question here. We've got 8x squared and we've got 4xy, so the introduction of a different letter here. Let's have a look what happens following the same process. So 8 and 4 both divide by 2, and they both divide by 4, so our biggest number there is 4, so we'll stick 4 on the outside, and they both have an x in. So we'll take the x out as well. Now that right piece there also has a y, but we'll have a look at how we make sure that we get that in a sec. So we've got 4x on the outside, they both divide by 4, and they both divide by x. So open up the bracket. To get from 4 to 8, we need a 2, and to make sure we get up to an x squared, we're going to need another x in there as well. Copy the symbol, plus, and then to make sure we get to 4, so 4xy we're trying to get to, well we've already got 4 on the outside, so that would be 1, so we don't need to write that. We've already got an x on the outside, so we don't need to put an x, but we do need to make sure we get the y there, so I just have to put a y in with that one. And if we expand that, we'll hopefully see that we're definitely going to get this this piece above here that we've got. So 4x times 2x, well 4 times 2 is 8, and x times x is x squared. Copy the symbol. 4x times y is just writing all the letters, 4xy. Brilliant, so it does work. Okay, so introducing some negatives. Same process though. We'll stick 2x in one bracket and x in the other, as we've got a 2x squared. And again, writing down the factors of 10, so 1 and 10, or 2 and 5. Now again, one of them is going to double, so we could have 2 and 10, or we could have 1 and 20. Are we going to be able to make 9 out of either of those? No. 2 and 10 we could make 8, we could make 12, but we can't make 9. And then 1 and 20 we could make 19 or 21, but we can't make 9. So it's not going to be 1 and 10, which means it's going to have to be the 2 and the 5. Got to be a little bit careful here because we have got negative 9 in the middle, so we are trying to make negative 9, but similar process to when we were factorising before. So let's double one of them, so we could have 4 and 5, or we could have 2 and 10. There we go, just doubling one of them. So again, we're trying to make negative 9, so it's going to have to be 4 and 5. We can't make 9 out of 2 and 10, but we can out of 4 and 5. We've just got to figure out, okay, well, which one of these needs to be negative? And actually looking at it, look, we've got a positive 10 at the end, so they're both going to have to be negative. So it's going to have to be negative 4 and negative 5. So I just want to make sure that that number above the negative 4, the 2, goes in the bracket that's going to be doubled. So on the right hand side there we want negative 2, that's going to allow us to get negative 4, and on the left bracket there we'll put the negative 5. And again you can just expand that to just double check, so 2x times x is 2x squared, 2x times negative 2 is negative 4x, negative 5 times x is negative 5x, and then negative 5 times negative 2 gives us the positive 10 at the end there. And tidying that up, look, these two here do make my negative 9. We get 2x squared minus 9x plus 10, and it matches what we were looking for. So you'll have probably noticed we've got a coefficient bigger than 1 on the x squared here. So we've got to take a little bit of a different approach here. I need to factorise this so that I've just got a 1x squared there to start with. Okay, so taking out a factor of 2, we get 2 lots of x squared minus 5x plus 4. Brilliant. Now we've got something that we can actually complete the square for. So if I have a look at just this quadratic in here, that's what I'm going to complete the square for. I'm going to ignore that the 2's there for the moment. So following the same process as before, so just completing the square for this, we get x minus 5 over 2 squared, and then we need to figure out what number is going to go at the end there. So figuring out what number goes at the end, let's have a look. Negative 5 over 2 times negative 5 over 2 would give us 25 over 4. And if we simplify that, what does that become? That's 24, so it's 6 1/4. Now we don't want 6 1/4, we want we want 4 at the end there. And in order to get to 4, we'd have to take away 2 1/4, so minus 2 1/4. There you go, minus 2 1/4. Now we need to reintroduce this 2. So this 2 was there. Now that 2 doesn't just disappear. Actually, this whole thing has to be multiplied by 2. So I'm going to bring that back in, and now we have to multiply that 2 out. So it's the same process. We just had to factorise the 2 out, and now we put the 2 back in. So if we times both of these by 2, we have 2 lots of this bracket, 2 lots of x minus 5 over 2 squared, and 2 lots of this negative 2 1/4, and 2 times negative 2 1/4 is negative 4 1/2, or 4 2/4. There you go, negative 4 1/2. So that's that times that 2 back out. Now we just need to finish this off to find the turning point. So our turning point is still this number here for our x coordinate, so positive 5 over 2. So 5 over 2. And then the y coordinate is still just this one at the end here, so negative 4 1/2. There we go, and there's our coordinates of the turning point. So you've got to have a look at this question here again. Just rewatch it again if you're not sure. So factorise the 2 out in the first step, or whatever it is, then complete the square just like normal in the second step, but then just reintroduce this 2 back in, and then multiply both things by 2 for your final step, and again just reading the turning point just like we did before. So a few extra steps there. We've got the fractions involved, so it is a little bit trickier. Okay, so here's our question. By completing the square, state the coordinates of the turning point for the graph of, and then we have y equals 10 minus 4x minus x squared. Now we already know that it's sloping this way, and that turning point, that point right at the top of the curve there, is what we're trying to find. Now with the process for this is pretty much the same as obviously looking at completing the square normally. So obviously I will link the video in the description for completing the square, so make sure you've checked that one out first, because this is going to be a little bit harder than that one, but the process is pretty much the same. Now what we need to do to start with, and this time it does matter, but we're going to take that factor of -1 out, okay, and it is very important that we do actually take that factor out and show that in this one. So this is the expression we're looking at, 10 minus 4x minus x squared. And if we take that factor of -1 out, inside the brackets, and again I'm going to reorder them, I'm going to put the x squared first, we'll get x squared, that'd be plus 4x, and it'll be minus 10. Now from there, what I'm going to do is I'm going to kind of ignore the fact that that -1's there, and I'm just going to complete the square for what's inside the bracket like we would normally. So again, when completing the square, we're going to halve the coefficient of x, so it would be x plus 2 in brackets squared. When we expand that, we get 4 at the end, and we want to get back to -10. Remember, -10 is in our original one. So to get from 4 to -10, it'd be -14. So that's that part in the bracket in completed square form. If we expand that out, it would match the one above. But this is where we have to remember that there was a -1 there. Now what we have to do is we have to multiply that -1 back into our expression. And I'm going to introduce a second set of brackets, because obviously we already have one set of brackets there. I'm going to put the -1 back on the outside. Now when we multiply that back in, it's easy enough. We have to multiply this bracket by -1. We don't actually have to do that. You can just stick the -1 at the start of the bracket. So -1 lot of this x plus 2 squared. And then when we multiply the -14 at the end by the -1, that's easy enough. That just swaps the sign. So that'll be plus 14. So that's that there in completed square form. And just like normal, we get our coordinates from this. So the x coordinate of the turning point is the opposite of the +2, and obviously I am going a little bit quicker than I would on the normal completing the square video, so do check that one out first if this is a bit beyond you. So -2, and let's put it up by a diagram, -2 would be the x coordinate, and the y coordinate is just that number at the end, which is positive 14. So it's -2, 14, and that right there is the coordinate of our turning point or maximum point for this particular graph. So there we go, that's what we're going to find. Obviously our final answer for this, the turning point, is -2, 14. And following on from this, we could actually draw even a more accurate sketch now of one of these quadratics, because we can factorise and solve it to find the solutions, and we can complete the square in order to find that turning point. Okay, so here we've got a slightly different question. It says the graph of y equals k to the power of x, where k is a positive constant, is shown. Find the value of k. Now that word constant just means that it is not necessarily a whole number, it could be a fraction as well. So when we're having a look at this, we just need to figure out how we're going to approach it. So we know it's going to be y equals k to the power of something, and we can always write that down just to remind ourselves of that. Y equals k to the power of x. Now what we're going to do is we're going to try and figure these out. And what we can do is we can pull some coordinates off of our graph. Now we know that with a graph like this, it's going to go through 0, 1. This one's slightly different to the ones we were looking at though, because this one is actually sloping downwards. So something is going to be different in terms of our value of k. And that word there where it says constant gives us a little bit of a hint. It means it's not necessarily going to be a whole number, so maybe k is going to be a fraction this time. And hopefully once we've seen this, we'll recognise that these downwards sloping exponential graphs do have a different value in place of k there. Now in terms of how we go about this, we could pick the coordinate 0, 1. Let's just have a look at that one and how we'd approach it. Now we know that 0 is the x coordinate and y is has got a value of 1. But if we were to plug this into our formula, we would have 1 as our y value is equal to k to the power of 0. And that leaves it a bit open-ended, because we know that no matter what goes in place of that k, we're always going to get the value of 1. So that's not particularly any help to us. So we're going to have to go for a different coordinate. Let's find a different one. Now there's a couple that I can see here, both in the negative region. I think it's a bit difficult to find a good one in the positive region there, as they're a bit small. But if we have a look, where does -1 land? -1 lands at 2. So we've got a coordinate there. What about -2? That lands at 4. Maybe -3. That lands up here at 8. So we could pick any of those. I'm going to go for the -1 being at 2. So what we have is 2 as our y coordinate, so 2 is equal to k to the power of our x coordinate there, which is -1. And again, here is where you have to have a really good understanding of your, well, I want to say fractional and negative indices, but in this case it's just negative indices. So again, I'll link that in the description, but this is almost a reverse negative indice. So we have to figure out what value to the power of -1 gives us a value of 2. And essentially we just have to reverse that power. We know that a negative power does the reciprocal. Now at the moment, 2 is 2 over 1 if we were to write that as a fraction. It always looks a bit weird writing it as 2 over 1, but it just helps to visualise that reciprocal. So if we flip that over, that becomes a half. And obviously it's a power of -1 there, so that means there were no powers involved, so a half is equal to k, or k is equal to a half. Now that's our value there. Let's have a look at maybe if we'd pick the -2, how we'd approach that, because we might not have a nice value on the -1. Now if it was the -2, which goes up to a value of 4, this one here we're looking at now, then I would, instead of putting these values in, so I'd have 4 is equal to k to the power of -2. And again, we can take the same approach. We know that 4 is 4 over 1. There was a reciprocal involved, so if we flip that over, we get a quarter, which is going to be equal to not k to the -2, but just the k squared now. After now we've reversed that negative power. And in order to get rid of the k squared, we would now need to square root both sides. So we would have to do the square root of both numbers there, and we would get 1 over 2, which is equal to k. And there we go, we found that value of k. K is equal to a half. So this is really just highlighting a different technique that we might have to use with some of these harder questions, where we might just have to pull a coordinate off the graph and sub it into that equation. Okay, so this question says Frank, Lewis and James share some money in the ratio 2 to 4 to 3. James gets 90, work how much Frank and Lewis receive. So again, we've got 3 in here, but we've got Frank, we've got Lewis and we've got James, and their ratio is 2 to 4 to 3. Now it's not saying that they all share 90, it's not saying that one gets £90 more than the other, it is saying specifically that James, who is on the right there, gets £90. So that is £90. Now what you can think, obviously that is 3 parts, that's the number above, so we could just say £90 equals 3 parts, and there we go, take the same approach. Or when it comes to a question like this where it actually gives you the answer, you could just think logically, well, what do we do? What do we times by to get from 3 to 90? Hopefully you can spot there, that is times 30. Now that is just a logical approach to what we're going to do anyway, because obviously if we've got that £90 is 3 parts, to get the value of 1 part like we have on all the others, we're just going to divide by 3, and we'll get the value of 1 part being 30 quid, and that's what we've done as a logical approach anyway, it's just that we're actually writing it down now. So anyway, if we're going to times them all by 30, we can just do that straight from the ratio now. Up here, we could just say, alright, well we just need to times all of these by 30. So times that by 30, that would give us 60 for Frank. And timesing this one in the middle by 30 as well, 4 times 30 is 120, and that will give us 120 for Lewis. There we go, and that's all that their values there. Obviously we can write that all down to the side. 2 times 30 is 60, 4 times 30 is 120, and 3 times the 30 is 90, but we already had that. There we go, so obviously we've answered how much they both got. Frank gets 60, Lewis gets 120, and again we could be asked how much they all share together, so you could do 60 plus 120 plus 90, and that would give us the total there, which is 270 between all 3 of them. So it just depends on what the question's asking, but there's just a couple of things to be thinking about. Obviously you just need to have a look at the words, allocate the amount of parts to the amount of number that you're given, whether that be all of them, whether it be one of them, or whether it be a difference between them. Okay, so Frank invests £8,000 for 3 years in a savings account. He's paid 2.4% compound interest in the first year and 0.5% compound interest per annum for each year after. And that word per annum again just means per year. How much did Frank have in his savings account after 3 years? Now for this one here, we're going to have to take it in 2 steps, because in the first year we get 2.4%. So we can work out how much he gets in the first year, and then we'll have a look at this 0.5% following that. So in the first year, and I'm going to label this, I'm just going to put year 1. So in the first year he gets 8,000, and we're going to multiply that by the multiply for 2.4%, so 1.024, and we're not going to put any power with that because it's only in the first year. You could put the power of 1, but I'm just going to work that out there. So 8,000 times 1.024, no powers involved, and that equals £8,192. So at the start of year 2, which is what we're looking at, year 2, he now has 8,192. Okay, so that's the amount that he's starting with in the second year. Now for the next 2 years, because it does say obviously this is 3 years in total, so we've already done the first year, so we've now got 2 years at 0.5%. So don't forget that's only going to be 2 years and not the 3. He's going to get 0.5%. So we just have to figure out how we're going to write that as a decimal. So 0.5%, well 1.0 is what we always put. There's not even a whole percentage, so it's another 0. And then for that 0.5%, like the 4 above, we've got the 5 at the end there. So you've got to be very careful that you don't accidentally put 1.05 when it's a 0 point something percentage. Okay, we've got 1.00 and then that 5 represents the 0.5%. Now it's 2 years at that rate, so that one there we are going to put a power of 2 to make sure we get the 2 years there, and we'll see what we get. So 8,192 multiplied by 1.005 to the power of 2, and that gives us our result here. So we have £8,274, and to the nearest penny it's 12p. There we go, £8,274, 12p. It doesn't say how much interest does he earn, it says how much does he have, so that's our final answer there, £8,274 and 12p. Okay, so Ava invested £8,000 for 3 years in a savings account. She was paid X% per annum in compound interest, and at the end of 3 years she had £8,589 and 93p. Work out the value of X. So if we take the same approach here, trying to write down what we know, we've got £8,000. We're going to multiply that by X%, which we don't know what it is, so let's just put X in there. It's going to be to the power of 3, and it's going to give us the answer £8,589 and 93 pence. Now again, we could just guess numbers, remembering it's going to be a 1 point something number, so you could just guess numbers like 1.02 and see what you get. You could just put that in, that'd be 2%. Okay, remembering obviously the percentage is in that 1 point number like we've been doing in the previous questions. But if we actually just type that in, let's see what we get. We get 8,000 times 1.02 to the power of 3, and we get £8,489 and 66 pence. Now obviously that's not high enough, so we'd have to go higher again. So maybe we could try 1.03. Try 1.03, which would be 3%. So have a look, go back into the calculator and change that. 1.03, we get £8,741 and 81 pence. So it's somewhere in between 2 and 3%, and it wouldn't take you too long to actually try these out. But obviously that is quite a time-consuming method, just typing in different little decimals there. So you could try 1.025 and then go higher or lower again. But there's actually a simpler way of doing this, and it's just about rearranging this little equation that we've got written here. So if I want to have x cubed on its own, bearing in mind it's 8,000 times x cubed, I could divide both sides by 8,000. So if I divide both sides by 8,000, that'll give me x cubed on its own. So divide both sides by 8,000, and we get x cubed equals, and let's actually go about doing that, 8589.93, and we get 8,000, sorry I've not actually typed the divide in, divided by 8,000, and we get 1 point, let's have a look, let's write this down. X cubed is 1.0737. What else we got? 4125. There you go. So x cubed equaled this number here. Now if I want to find out what x is, I can just do a cube root, because to find out what the what x is there, if x has been cubed, if we do the cube root, that'll tell us what x is. So if I cube root both sides, let's cube root that, and we get x equals, and you have to be able to find your cube root button. Normally it's behind the square root button, so I'm going to press shift and then my square root button, and it brings up my cube root. So obviously just make sure that you can figure out where that is, and then I'm just going to press the answer button, or you could type that number in there. But if I press equals, and let's have a look what we get. We get 1.023999818. There we go. Now, obviously the percentage here that the person's got is not going to be all these little decimals here. Okay, so obviously because the amount of money at this point here with the 93p has been rounded to the nearest penny, which it probably wasn't bang on, okay, that's going to affect this decimal down here. So we're going to have a look at what it is to the nearest few decimal places. So we know that this 2 here represents 2%. So we know we've definitely got 2% there. There we go. After that, it's going to be 2 point something %. Now, it's not going to be that 3 there, because afterwards it's 999. So it's very, very likely that that 3 was actually just a 4, and it's most likely that that was going to be 2.4%. There we go. Obviously we don't know exactly because obviously we don't know what it was rounded to, but it's very, very likely there that it was 2.4%. Okay, so we're just getting it to that nearest little single decimal of a percentage there, 2.4%. So I'd give my final answer there and I'd say it was 2.4%. There we go. Obviously you just need to remember that obviously in those previous questions we found the 2%, we found the 3% by adding it onto the 1, so it was 1.03 up here, or 1.02 in the previous questions. So that 1.023999 is that 2.4% hidden within there. Okay, and that's how we find one of those. Obviously you could have, at the starting point though, when I typed in these 1.02s, 1.03s, you could have just tested it out. I think if we'd have tried out 1.025, then it would have been just slightly too high. We might have then gone for just 1.024, and you'd have found that that would have given you the answer pretty much bang on. So there's two different ways of doing it. This is obviously the rearrangement way. So one, obviously to make some notes on there, and obviously figuring out how you do your square roots and your cube roots on your calculator, or potentially a fourth root if it was for 4 years or something like that. So in this question here, it says Ollie drove 56 kilometres from Liverpool to Manchester, and then he drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour, and he took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive. So the first thing is we've got all this information, so we can start putting that into our table. We've got this one here, a speed, and we've got this time here, which is in minutes, and that's the first time minutes has appeared on one of these questions. But let's have a look at what happens when we just start putting these in. Now, if I go for this journey, let's have a look. We've got L to M, Liverpool to Manchester. Then we've got Manchester to Sheffield. And we've got the overall or the total journey. There we go. And again, we're looking for a speed, a distance, and a time. And again, I'm going to put down my speed equals distance over time formula triangle. There we go. So if I start to fill in some of these, and let's just put all these grids in to start with, let's see what we've actually got. So we've got 56 kilometres for the first bit, that's a distance, and we've got 61 kilometres for the next one, and we can add those together. 56 plus 61 is 117 for our total distance. So we've got an average speed from L to M of 70, and we've got a time of 75 minutes. I'm going to put that there, 75 minutes. Now when it comes to this question here, we'll have a look at what we're going to do with that 75 minutes, because that's our little change in this particular question. So we'll come back to that, but to start with we can actually work out this time here, can't we? So we've got time is distance divided by speed, so we can do 56 divided by 70, and 56 divided by 70 gives me 0.8. Right, there we go. So we've got 0.8 and 75. Now obviously we can add together distances and we can add together times as well, but doing 0.8 plus 75 seems a bit bizarre. 75.8 is not going to be correct there, because the 0.8 is in hours and the 75 is in minutes. So before I add these together, I want to make sure that they're in the same units. Now in this particular question, we're obviously working out a speed, and our speed up here in the question look is in kilometres per hour. So we want to have that 75 minutes in hours. So for the first thing that we need to make sure we do is make sure that we get an amount of hours there. So you might know what that is in terms of hours, but if you don't, you can just divide it by 60. So 75 divided by 60 is 1. Let's just type it in just to make sure we get this on the calculator. There we go. We get 1.25, which makes sense because we've got 15 minutes additional on top of that 60, and 15 minutes is 1/4 of an hour. So that's going to be 1.25 hours there. There we are. And now we can actually go about working out that total time. Okay, we can add those two together now and we get 2.05. Okay, so 2.05 hours. So we're looking at this now. Actually, look, we don't even need to work out this speed box here. It doesn't ask for its speed between Manchester and Sheffield. We've now actually got all our pieces that we need to get our speed for these for this final total part of the journey. So actually, we didn't even need to work out one of those boxes. So we can just go straight ahead and work this one out here. So speed is distance over time. So we have 117 divided by 2.05. Let's see what we get. 2.05. And we get a pretty nasty number here. We get 57.07317. There we go, and there's a recurring decimal above the 0 and above the 7. Now it's more than likely that this type of question here would then say give it to the nearest kilometre per hour, or give it to the nearest decimal place or something like that. But obviously just remembering in terms of an exam, if it doesn't say how to round the answer, you don't go about rounding it in any way at all. You would just write that full answer down there, and we would say that there to in kilometres per hour. There we go. Quite an unlikely answer to appear in an exam if it didn't want you to round it, but there we go, it would tell us in an exam how to round that particular question. Okay, so when looking at population density, we can think about a formula for this. So to work out the population density, which I'll write as PD, you would actually do the population, so the amount of people, population, and you would divide that by the area. Okay, so that is what we would do to work out the population density. Let's just write that P there. So in order to go about finding the population, we could think about rearranging this formula, but we can just apply a logical approach. It says the area of this country is 5,000 kilometres squared, and it said the population density is 315 people per kilometre squared. So in every one of those kilometre squareds, there are 315 people. So it seems quite logical that if we have 5,000 kilometres squared, that we would just do 5,000 multiplied by the 315 people that are in every one of those. Now we can work that out on a calculator, and it comes out as 1,575,000 as our population. So we could put people there, but that is 1,575,000 people. Now that makes sense with our formula as well, because if we were going to rearrange this formula to get population, we would want to times both sides by area in order to remove that divide there in our fraction. So that would mean we had to have the population density multiplied by the area would be equal to the population. Okay, but you can apply a logical approach here because it makes sense for us to multiply when every one of those kilometre squareds had 315 people. It says Ben is going to cover the floor with wooden floorboards, and it gives us a diagram of the floor. It says one pack of floorboards will cover 2.25 metres squared. How many packs of floorboards does Ben need? So the first thing that we actually want to work out here is the area of this compound shape. And there are two different ways of doing that. So as you can see, it's this kind of L shape at the moment, and it's made up of two rectangles. So we have to split this up into individual rectangles so we can work out their areas. So you have two ways of going about that. You could go across and you could split it up into rectangles that way, or you could go upwards and you could split it into two rectangles that way. Of course you could do both and you could split it into three rectangles, but that's probably going to make a little bit more work for yourself. So let's just go with splitting it across and working out the area of these two. So for the bottom rectangle there, you have a length and a width of 3 and 2. So that's going to give us an area of 6 metres squared. Again, just doing 2 times 3. For the top one, you have a length and a width of 4.5 and 2. So if we do 2 times 4.5, that is going to give us an area there of 9 metres squared. So overall, we can work out the actual total area. And 9 and 6 is going to give us a total area of 15 metres squared. Again, just showing you're working out and how you've added them together. So the area of the floor is 15 metres squared, and it said in the question that one pack of floorboards will cover 2.25 metres squared. So in order to work out how many packs that we need to buy, we have to do 15 and divide it by the 2.25. So if you have a calculator, you can just type in 15 divided by 2.25, but if not, you are going to have to just count up in 2.25s. So what you could do is just start making a list. You could do 2.25 plus another 2.25, which would be 4.5, and you could build your way up. But if we do this on a calculator while we're practicing, you'll see that you get the answer 6.6 recurring. Now obviously we can't go into a shop and buy 6.6 recurring packs. So when it comes to a question like this, we have to actually round that up. The reason that we have to round it up is obviously if we were to buy 6 packs, then we wouldn't have enough. And if we were doing this in real life, we would have to just buy more packs than needed, and we would have some spare left over at the end. So when we get this scenario, we will round that up and we would say 7 packs, and that would be the final answer for this question. Obviously the question could go a little bit further. It could tell you the cost of each pack and potentially ask you to work out the total cost of buying them. So you have to remember to round it up, because in real life, again, we would have to buy the additional pack there, which would give us some left over, but that would be absolutely fine. Okay, so the surface area of a cylinder just requires a little bit more working out. Obviously we're looking at area, so it's going to be a little bit different anyway, but we have just got a little bit more working out when we're working out the surface area as opposed to when we're working out the volume. Now when we're working out the surface area, we're going to work out the total area of all the different surfaces. And you can see we've got a circle on the top, and we've already been working out the area of that, and the one that you can't see that's on the bottom. If I try and highlight that in, you've got a little circle down there as well. So we're going to have to work out the area of those two. Obviously they're both identical, so we only need to focus on the one on the top, and then we can double it up. And then we also have another surface here, and that is the curved surface going around the outside of the cylinder. And we'll talk a little bit more about that in a sec. But if we start with the circles, as we've already been working those out, we should be able to get those done nice and easily. So for the area of the circle, obviously it's pi r squared, so we're going to do pi times the 9.3 squared, and that's going to give us the area of the circle. And if we write that into our calculator, what have we got? 271.716. Now it wants the answer to 3 significant figures, so what I'm going to do is I'm just going to keep my answers to about 3 decimal places, which in this case for these looks like it's going to be about 6 significant figures for this one, but I'm just going to keep it to a much higher degree of accuracy than we want in our final answer. It's good practice just to write them all down, but I think we'll be absolutely fine keeping it to those 3 decimal places. So we've got 271 point, and we get 716. Now, and there's obviously a few more decimals after that. Now obviously we're going to double that up as we have 2 of these circles. So if we times that by 2, that's going to give us the total area of those 2 circles. So I'm just going to do times 2 on my calculator straight away, and there we go, we'll write down these. So we have here 543.43, and actually when we double the answer that I had on the calculator, that's going to round up to 433. Okay, so there we go. There is the answer on the calculator. Obviously there's a little bit of difference there. Obviously with the number above, I've not actually doubled that number, I've doubled the one on the calculator. But if I was to just, in fact, let's just write everything down, just to avoid that little bit of confusion there. So we have 4326972. That's the full answer that I've got on my calculator. So that is the total surface area of the 2 circles. Now we need to have a look at, as we mentioned, the curved surface around the outside. Now if you imagine that if this was like a hollow cylinder, and we took a pair of scissors and we cut down the centre just here, and we unravelled the cylinder and flattened it out, what we would actually have is a rectangle. Okay, so we would have a rectangle, it would have a length here of 12.4, the height of the cylinder, but we would need to work out the length going along the top. Okay, this length just here. So in order to get that length there, if we look at our cylinder, that length there is actually the length that's going around the outside of the top there, around the circumference of the circle. So actually that length that we're trying to work out on the top of that rectangle, let's see if I can get rid of that arrow there, is actually just the circumference of the circle. And the formula for circumference is pi times diameter, or pi times 2r, depending on which formula you use, but this one seems to be more recognised, so we'll go with circumference is pi times diameter. Now obviously that means we need to know the diameter of the cylinder here, and we've got 9.3 as the radius, so if we double that we get 18.6 as our diameter. So in order to work out the length along the rectangle there, we can do pi and multiply that by 18.6. Obviously that has a numerical answer, but I'm just going to leave it as pi times 18.6. So to get the area of the rectangle, that's nice and easy, it's just length times width. So if the length is pi times 18.6 and the width is 12.4, if we multiply those all together, let's see what we get. Pi times 18.6 times 12.4, and that gives us a final answer of 724.576. And what else have we got? 9296. There we go, just about fit that in. So that is the curved surface area around the outside of the cylinder. Now obviously we need to add these all together to get the total area, so we're going to add these 2 numbers together, and that's going to give us our total surface area. Let's just put a little plus there. Obviously just being careful with this sort of question, we're going to add those up in a sec, but obviously just being careful that that curved surface area there, we're getting the circumference as the length of that rectangle. I think that's the difficulty here, remembering to do that when you've got this type of question. But there we go, that's how we're going to work these out. We just need to finish this off by adding those together. So I'm going to do that inside the cylinder there. So we've got 724.576, the curved, plus the two circles, 543.4326,972. There we go, pressing equals, and we get a final answer here of 1,268.009627. And again, three significant figures. So let's round that off. 126, the number in front of the line is the nearest 10, so that's going to be 1,270, and again it's about area this time, so that's going to be centimetres squared. So there's our final answer, 1,270 centimetres squared for our surface area. Okay, so obviously you've got the two circles to work out and the curved part using that circumference for the length of the rectangle. We've got the vector A, which is 5/3, and the vector B, which is 4/2, and it wants us to write down A plus 2B as a column vector. Now the process to actually go about doing this is quite nice and simple, but it's important to understand why we go about the process we do and how it works. So that vector A, 5 and 3. Now the number on the top represents the movement left and right. So a number 5 means a right movement of 5. Okay, if it was -5, that would be going left by 5. Now the number on the bottom represents going up and down. So after it's gone right by 5, it's then going to go up by 3. So there we go, it's going to go up 3 as well. So if we think about this as a start and end point, it's going to start over here where we started, and it's going to end just here at the top of that 3. So the actual vector itself would go from there to there. There we go, and we would put a little arrow on there just to indicate that it's gone in that direction, and that right there would be the vector A. Now we could actually just get rid of these movements now. I'm going to leave them on there, but obviously the actual vector itself is that vector there with the indicated arrows showing the direction that it's gone in. And that's our vector A. And we could do exactly the same for vector B. We're not going to do that because obviously it's just going to be the same. It's going to go right by 4 and up by 2. But essentially what we're being asked to do here is to combine these vectors. So we've got that it wants us to write down A plus 2B, or 1A plus 2B. Now that means it wants us to do the movement A, which is going to go across 5 and up by 3, and then it wants us to do the movement B, and it wants us to do that twice. So we're going to go across by 4, and then across another 4, and then up by 2 and up another 2. So in order to combine all of that, and just to show the total movement that we're doing, we can actually just do it numerically. Okay, we don't have to do these drawings, or it is good to know these drawings for future questions and just obviously being able to understand the question. So the vector 5/3, we're just going to write that down, 5/3, and that's our vector A. And we're going to add to that 2 lots of B. Now I'm going to put this outside the brackets, so I'm going to do 2 lots of 4/2. Now you didn't have to write down 2 lots of that, we could have just straight away times them by 2. So if we write that out as well, we've got 5/3, and then we've got 2 lots of the other ones, we've got 8/4, just doubling those vectors in there, and that's what we're going to add together. So that's a movement of 5 across and 8 across. So if we just add together those top numbers, in total there, that's a movement across of 13. And on the bottom, we've got 3 and 4, and that's a total movement of 7 going up. So our final vector there is 13/7, and it is as simple as that with column vectors. It's just a case of finding the 2 vectors that you can add together and literally just adding those together, the top numbers, and adding together the bottom numbers. Now it says Josh gets the bus to and from school each day, and the probability that his bus is late to school is 0.14, and the probability that his bus is late home is 0.32. Work out the probability that exactly one bus is late. And we'll have a look at that language in a sec, exactly one bus is late. But let's just have a look at constructing our tree here. So we have one option here, and let's think about this as his journey to school. So let's just label that as to school, and it says it's either late or not late, and I'm just going to put not late for that. So the probability that's late is 0.14. So if we take that away from 1, or think about it as a percentage of 100, so that's 14%, and 100% take away the 14% would leave us with 86%, or 0.86. Obviously just take your time with that. These 2 branches here have to add up to 1, so always just double check that they do actually add up. And that's the journey to school. Now obviously 2 separate journeys there, and then we've got to think about the journey home. And again, it mentions that it's either going to be late, so I'll label that late, and not late. And again, I'm just going to quickly draw in the one below as well, because these are going to be replicated. They're going to be the same, the top and the bottom. So it says the probability is late home is 0.32. So we can put that in the late there, and we can put it on the late down here as well. And again, that's 32%, and 100 take away 32% would leave us with 68%, sorry. So that would be 0.68. There we go. And again, just double check that they definitely add up to 1. Now this, again, this question said exactly 1 bus is late. So in this time, late, late, at the top, that's not exactly 1, so we don't want that one. We've got late and then not late, that's exactly 1. We've got not late and late, that's exactly 1. And then we've got 2 here where they're both not late, so that's definitely not exactly 1. So we've got the 2 options there that we want. We've got the ones in the middle, and they're the 2 that we need to work out here. You've got to be careful with this one because these 2 in the middle aren't going to be the same like they were in earlier questions. They are actually going to be different probabilities in the middle here, so don't just work out one and double it. Always just work out both of them. So going up the late, we go through 0.14 and 0.68. So if we work that one out first, we've got, and let's see if we can do this to the side. So we've got 0.14 multiplied by 0.68, and that gives us a probability there, which I'm going to do on the calculator. 0.14 times 0.68 gives us a probability of 0. That's a bit longer. Let's have a look if we can fit it in. 0.0952. There we go, and that is our first probability, 0.0952. Let's have a look at our second one. So for the second one, obviously we could be not late and then late, and that's going to be, let's see if I can fit this in, 0.86 multiplied by the 0.32 there. And again on the calculator, 0.86 times 0.32 gives us a probability of 0.2752. 0.2752. There we go, and that's the probability of that route. Now obviously, just like before, we've got 2 outcomes here. We've got late and then not late, or not late then late, so we need to add them both together. So if I do that up here, we've got 0.0952, and we need to add to that 0.2752. There we go, and if we add them together, 0.0952, I'm going to do it on the calculator, we get 0.3704. 0.3704, and there we go, there's our final answer combining those 2 probabilities. Okay, so slightly nastier in terms of the decimals there, but obviously you can see that the process is the same. It's all about just constructing that tree very carefully and making sure that you go through the appropriate routes. Obviously, if you're happy to do this without a tree, you can do, but I would advise a lot of people obviously just prefer the visual method here, actually seeing the journey. Okay, it says on an activity day, students play one sport, either football, hockey or tennis, and it said there are 120 students, 30 are boys, 12 of the 38 students who play hockey are boys, 35 of the 45 students who play football are girls, 1 of the girls is chosen at random, write down the probability to play tennis. So this is very similar to our last one in that we're going to have a very similar table. Okay, we're going to have a nice table drawn out. We've got boys, we've got girls, and we've got a total, which I'm now just going to label as T. Okay, you can write the full words in if you want. And then I've got 3 options and a total at the end. So we've got football, we've got hockey, we've got tennis, and again a total, and then I'm just going to label that as total as I've got another T up there. Right, okay, so putting all the pieces that we've got there are 120 students, so let's put that in our total down there, it's 120 in total. We've got 30 of the students are boys, so in the boys column, total is 30. The next one there, we've got 12. Let's have a look. This has got 2 bits of information here. Look, it says 12 of the 38 students who play hockey are boys. So that says 12 of the people that play hockey are boys, and that's out of the 38 that play hockey. So 12 are boys. Let's have a look for the hockey column. 12 boys out of 38 down there. And we've got the same piece of information here with the football. It says 35 of the 45 who play football are girls. So in the football column, we've got 35 are girls out of the 45. There we go, so that allows us to put 2 bits of information in. So now we can go about actually filling in the rest of this table. So let's have a look then. We've got the first column there, that has to add up to 45, so we're missing 10. So we've got 10 boys. I'm then going to go across the top here. So at the moment, along these 2, we've got 22 so far. We need to get to 30, so that's an extra 8. Let's have a look where we can go now. We can go down this way as well. Okay, we've got 30 boys, so that's going to be 90 girls to make sure it adds up to 120. And where else can we go from here? We've still got this missing box here as well. So at the moment, these two, what do they add up to? We've got 40, 50, 60, 75, 83. That adds up to, we need to get to 120. So that is going to be an extra 37. And then we've also got the one above that now, and obviously these two in the middle. So moving down this way, we've got 12 there. We need to get to 38, so that's an extra 26. And we've got 8 here, we need to get to 37, so that's an extra 29. There we go. And as I said before, just a quick check that these still add up to 90. So 35, add 26 is 61, plus the 9, 70, 80, 90, yes, that all adds up, so that's absolutely fine. Right, there we go, so that's our table filled in. And then let's have a look. It says one of the girls is chosen at random. Okay, so one of the girls is chosen. Write down the probability that they play tennis. Okay, so the language is different here, and this is important. It says one of the girls is chosen. So if we have a look, how many girls are there in total? There are 90. So one of those 90 girls is chosen. So our probability this time is going to be out of 90. Just got to watch out for the language there. What's the probability that they play tennis? Well, there are 29 there that play tennis. So that's going to be 29 out of 90. Okay, so obviously the language is different there. It said one of the girls is chosen, so that specifically, that dictates that you are having to choose from one of the 90 girls, and then out of that 29 of them play tennis. There's our probability. And again, as with all probabilities, you do not have to simplify that. You can just leave it as it is. Again, it's an important piece of information there. It tells us specifically that 29 out of 90 play. Not that that one does simplify, but if it does, you don't have to simplify it. Okay, although you wouldn't be wrong for doing so, but it's just going to waste a little bit of your time. So in this question here, we've not actually been given the lowest, highest and median, etc. We have been given a list of the 15 people waiting to be served at a garden centre here and the time in seconds that they spend. So fortunately it's been put in size order, but we're actually going to have to find the values ourselves. So it's not too bad. We've got the lowest one there, 5, and the highest 44. Obviously we'd have to rearrange this ourselves if it wasn't put on there, but let's have a look at actually drawing the box plot. So let's just start putting some of the things in that we know. So 5 is the smallest, 44, the squares go up in ones this time, so I'll try and do as best as I can. Let's have a look. Looks like 44 there. And then we've got to find the other pieces ourselves. So we'll start off with finding the median. Now there's 15 people, so obviously to find the median here, we just add 1 and halve it. So 15 plus 1 is 16. And we're going to divide that by 2. So 16 divided by 2 is the 8th person along. So let's just go along. We've got 1, 2, 3, 4, 5, 6, 7, 8. There we go. So 25, and that is our median. Let's just label that in. There we are. So the median. So 25 is obviously halfway between 20 and 30. Let's put that one in there. And let's find our next one. So using what we did a minute ago, 15 plus 1 is 16. And if we divide that by 4, that'll find us our quarter. So we've got 16 divided by 4 this time rather than 2. Or obviously you could just halve the 8 and that gives us 4. So we're looking for the 4th person along. Let's do this in a different colour. So 1, 2, 3, 4. There we are. So 14 is our lower quartile. So 10, 11, 12, 13, 14 as best I can. That's there. And we can go 4 from the other end to get our upper quartile. So 1, 2, 3, 4. There we go, so 30. Let's plot that on 30. There we go, and then let's join that up as a box plot. There we are, so joining that up and finishing it off with those last little bits there. Right, okay, there we go. So if you haven't seen obviously that process before we're finding the median, because sometimes people just cross off from either end, just something to be thinking about there. Obviously you can apply a little bit of logic. If you have 3 people standing in a line, okay, you don't just halve 3 to get the middle, because obviously the middle is that second person there. You would do 3 plus 1, which is 4, divided by 2, and that tells you it's the second person that's in the middle. So I'm just applying that logic, obviously, from that little simple example, obviously, onto these 15 people standing in a line, and the same for the quarter of the way along, okay? So just add 1 and halve it, or add 1 and divide it by 4 to find out where the quarter is. Right, okay, so now we've got another box plot below. It says the box plot shows the distribution of the times that people waited to be served at Green's Garden Centre. It's obviously different to Rose's Garden Centre. And it says compare the distribution of the times at Rose's and the distribution of times at Green's. Okay, so if we have a look at what we've got here, there are 2 things that we're going to want to actually compare when we're looking at these box plots. One of those things is our big key important average here, and that is the median. And then the other one there, we're going to have a look at the interquartile range, but we'll discuss that as we go along. So all we want to do is have a look who has the higher median, or the other way around, who has the lower median. And the higher median is here in roses. We know that that median there is 25. And if we have a look, it looks like this one is 21 at greens. So I don't have to mention any numbers here. All I have to say is Roses Garden Centre, okay, has a higher median. There we are, and I want to add one more little bit of information in here, and that is adding a bit of context. So this is all about the time that they wait in the queues, I'm guessing. So I just want to say Rose's Garden has a higher median wait time. There we go. I don't have to mention any numbers. I'm just making a comparison and bringing in a bit of context. So I'm not just you know, stating a random fact here. I'm saying that the actual median wait time is higher at Rose's Garden Centre. Now there's one more thing that I want to compare, and that is the interquartile range, okay, which is a measure of how spread out these wait times are. If you think about what that interquartile range actually is here, this little gap in the middle, that's half of the data there. It's the central half. There's the first quarter on the left, then half of the data in the box, and then the last quarter at the end there. So that interquartile range, and again, I don't have to mention any numbers, but it goes from 14 up to 30. So that's an interquartile range of 16 there in terms of that wait time. Now if I have a look at the one below, there we go, that is ranging from 12 up to 35. So 35 take away 12 is 23, 35 take away 12 is 23, there we go. So the range there, or the interquartile range, is greater at the Greens Garden Centre. So I would say the interquartile range, or the spread of wait times, there we go, or I could say it in a different way actually. I could say the wait times are more spread out at Greens. It probably makes a little bit more sense just to shorten it down. There we go. The wait times, there we go, are more spread out at Greens. There we go. You could even say shown by the interquartile range. But obviously thinking about what that means, it means that obviously at Rose's Garden Centre there, with 16 being the interquartile ranges, those times are a lot more compacted into the centre there than obviously Greens that are a little bit more spread out. There's obviously an interquartile range of 23 in between those time frames there, shown by the box plot. So there we go. That is our last little bit of comparison there. So always make sure you compare the median, and then always make sure that you compare the spread, again, which is shown by the interquartile range there. I've just realised that doesn't really look very good. It doesn't really look like the word spread. There we go. Okay, so the wait times are more spread out at Greens Garden Centre. Now, just thinking about what we're actually finding here. Now, this first equation, we're going to be having a look at all these sorts of equations here, where one is a circle and one is a straight line. And if we think about that, what that would actually look like without drawing a full graph, if we had a circle and a straight line went through it, there would be two solutions there. There would be one where it crossed over here and another where it crossed over here. That is, of course, unless the straight line is a tangent, which could be quite hard for me to draw, but if it was a tangent, it might just touch the circle at one point there. So it could actually only have one solution, but the majority of the time these are going to have two solutions. Now let's get rid of that. Now, in order to solve a simultaneous equation, we have to think about eliminating one of the variables. So eliminating either the x or the y, just like when we have a look at normal simultaneous equations, but there's a different process when it comes to these harder ones here. So grab a piece of paper, grab a pen, make some notes. We're going to have a look at some of these questions. Now for this first one, it says x squared plus y squared equals 13. And the second one says, well, x equals y take away 5, or y minus 5. So essentially, if we can substitute, which we can substitute this y minus 5 in place of the x, because it says x equals y minus 5, then we can actually eliminate one of the variables there. Now the way to do that is if I just stick a bracket around this y minus 5, I'm just going to put that in place of the x up here, and let's see what we get. So getting rid of the x and putting the y minus 5 would leave us with this. We'll have y minus 5, and that is x squared, so that's going to be squared, plus y squared, and that equals 13. Now we've got an equation that has no x's in. Now as long as we've only got one variable in there, we can definitely solve it. Okay, but it's gonna form a quadratic, okay, with y's in, but we can actually definitely solve that. So if I just go about expanding this bracket to start with, obviously I'm going to take my time with the first one here, but I might skip a few steps as we move on. But that y minus 5 squared is a double bracket, so if we work that out first, we've got y minus 5, y minus 5. And if we expand that, let's see what we get. So y times y is y squared. and we get minus 5y, minus 5y again, plus 25. I'm obviously assuming that you are quite comfortable with some of the topics in this video here, so expanding a double bracket, and later on we're going to have factorising quadratics as well, and substitution, and a few other bits of maths. So I'm going to assume that you're quite comfortable with those if you are watching this video. If not, obviously check out the algebra series in my playlists. Okay, everything's there. Obviously don't forget those playlists are there, because there's quite a lot going on in those now. But if we have a look, if we simplify this, we get y squared minus 5y makes negative 10y, and then plus 25. So if I rewrite this equation here, let's bring it over here, we'll rewrite this, but rather than the y minus 5 squared, I'm going to obviously write that expanded version. So we get y squared minus 10y plus 25, and then we've got the plus, I've not actually written y squared there, let's fix that. I should say y squared there, plus that y squared, and that equals 13. Right, there we go. Right, so we can tidy this up because we've got those two y squareds there. So we can add those together and simplify that. So we'll have 2y squared. So 2y squared minus 10y plus 25 equals the 13. Now when it comes to solving a quadratic, we need to make this equal 0. So we need to subtract 13 from both sides. So if we get rid of that 13 from both sides, let's see what we get. We get 2y squared minus 10y. Take away the 13 from the 25 leaves us with 12, so positive 12, and that equals 0. Right, now we can solve this. Now we can do this in two ways. I can solve it from there, or I can have a look at all these numbers. Now all these numbers, or all these coefficients of y squared, the coefficient of y and the number at the end, they're all even. So if they're all even, we can divide both sides of this equation by 2. And if I divide everything by 2, both sides, obviously 0 divided by 2 is still 0 on the right hand side of the equal sign. But if we divide all of these by 2, we get y squared minus 5y plus 6 equals 0. Again, I've just divided everything by 2 there. Now, this is quite nice and easy for us to factorise. So we can factorise this as it is now. So 6, the factors are 6, we've got 1 and 6, or 2 and 3. So going into our double bracket there, we've got y, and we just need to get the right pairing here. That's going to equal negative 5 in the middle. And that's going to be negative 2 and negative 3. Now just be careful obviously, because you can make negative 5 out of positive 1 and negative 6, but we have got a plus 6 at the end there, so it's going to have to be negative 2 and negative 3. And that makes minus 5 in the middle and positive 6 at the end. Right, so we've got our two solutions for y. I'm going to bring those up to the top. In fact, I'm going to get rid of all this working out on the left. Let's get rid of all of this. Right, so we have for y, our y minus 2 in the bracket gives us y equals 2, positive 2. And our y minus 3 in the bracket gives us y equals 3. So we've got two of our y coordinates there, thinking about obviously what I mentioned at the start, that crossover point of the circle and the straight line. So we've got y equals 2 and y equals 3. Now we just need to find what x equals for both of them. So we've got this equation here, this second equation. I'm going to get rid of those brackets. We've got x equals y take away 5. So if x equals y take away 5, then I can find x for both of these coordinates. All I have to do is take away 5 from both of them. So when y is 2, we get x equals 2 take 5, so x equals negative 3. And for the one on the right there, we've got x equals 3 take away 5 when y is 3, so that gives us x equals negative 2. Right, so we've got our solutions there. So we've got y equals 2 and x equals negative 3, and the other one we've got y equals 3 and x equals negative 2. Obviously thinking about how you could write those as coordinates, so the coordinate for this one on the left here would be minus 3, 2, and the coordinate for this one on the right would be minus 2, 3. And there we go, there's our solutions for this simultaneous equation. Obviously we can pair up the values there. We could just say when x is negative 3, y is 2, and when x is negative 2, y equals 3. So it just depends on how the question's asking you to write your answer there, but we could also write it as coordinates, thinking about what that looks graphically. Now for any quadratic, we're looking at the quadratic when it is in this form, ax squared plus bx plus c equals 0. So we're having a look at these numbers here that are in front of the x squared, which in this case is we call a, in front of the x, which we call b, and the number at the end, which we call c. Now what happens is when this piece here is rearranged, it forms the quadratic formula. And as I said, if you want to see how it turns into the quadratic formula, I'll link that video at the top of the description so you can have a look. But when we rearrange this, okay, and there's quite a lot of steps in order to do that, we get this formula, okay, and it's x equals, okay, and on the top of this fraction that we're going to have here, we get minus b plus and minus the square root of b squared minus 4ac all over 2a. Now that there is the quadratic formula, and it allows us to solve a quadratic without actually having to factorise it, okay, because the times that we would use this is when quadratics cannot factorise. Okay, we could use it for quadratics to factorise, but it's a bit of a longer process if you are able to factorise it. So again, if you want to see how this is actually created, I'll link that in the description, but for the purpose of this video we're going to be using this formula, so make sure you have that one written down over there. X equals minus b plus and minus the square root of b squared minus 4ac all over 2a. And for the purposes of the GCSE exam, you do actually have to remember this formula, so it's worth writing it down and writing it down a few times until you're able to remember it. Although the best way to remember this is just to practice some questions. So for this one here, all we need to do is we need to identify what the values of a, b and c are, because you can see in the formula we've got a's, b's and c's. Now that's easy enough, all we have to do is have a look at our quadratic. But one thing that's really worth noting here is that the quadratic has to equal 0. That's absolutely key for a quadratic, because what actually a quadratic relates to is a quadratic graph. And if I was just to draw a basic little sketch of a quadratic graph, it would look something like this. And what we are finding is these 2 points here where it crosses over the x-axis, okay? And in terms of a little logical reason here, when it equals 0 is when y equals 0. And when y equals 0, that's anywhere along the x-axis, and I almost refer to it as being ground level. Now if it wasn't equal to 0, let's imagine it was equal to 5 or something else. If it was equal to 5, what we'd actually be finding is the points here where it crosses through when y is 5, and that would obviously give us two very different solutions. It would give us this one here and it would give us this one here, and we're looking at where it crosses the x-axis for those solutions, or sometimes called roots as well when we refer to the graph. So that's very key, they all have to equal 0. For the purpose of this video they are already going to equal 0, but just thinking about the future of this topic, the quadratic has to equal 0 in order for us to solve it. So let's have a look at actually solving this question then, and we'll pick out our values of a, b and c, and let's have a look. So for this quadratic that we have here, x squared plus 5x plus 3 equals 0. The number in front of x squared obviously isn't written, and that means that a is equal to 1. It's a 1x squared. The number in front of x there is positive 5, so I'll just write b equals 5. And the number at the end is the 3, so c equals 3. Now from there, all I have to do is put it into the quadratic formula. So forgetting about the x equals for a second, let's just put all the numbers in place of the formula and see what we get. So b is 5, so we have minus 5 on the top as it's minus b, plus and minus the square root of 5 squared minus 4ac. Now whenever I'm squaring something in my calculator, I always put it in a bracket. So let's put 5 in the brackets squared. I'll talk about that later on a later question. Take away, and then we have 4 times 1 times 3. And that's all over 2a, which is 2 1s, so 2. I'm going to put 2 times 1 though, just to emphasise the fact that I've substituted that 1 in place. Now there we go, we've put it into the formula. Let's get rid of this formula now. And we just need to actually get our solutions. Now one thing you'll notice is obviously we have this plus and minus, and that's because the square root of a number always has two solutions. Just thinking about the square root of 25, for example, the answer, which most people will say is 5, but it can also be minus 5. Negative 5 times negative 5 is also 25. So just by that very nature, we'll always have two solutions under the square root, unless of course underneath the square root is 0, in which case the answer will just be 0. But let's have a look then. So in order to do this, I need to do it once with the plus sign. So I'm just going to do this whole formula once and use a plus sign, and then I'm going to go back into my calculator and change it for a minus. Okay, so typing this into a calculator then. So I'm going to take the minus 5 and I'm going to use the negative button, obviously, rather than the take away to emphasise it's a negative. So negative 5 plus, and then I'm going to do the square root in brackets, 5 close brackets squared, take away 4 times 1 times 3, and on the bottom of the fraction, 2 times 1, which is 2. So I'll just put 2, press equals, and we get an answer. Now just to emphasise that that's the positive one, just by my working out here, I'm just going to put a plus sign so I know that's the one I've done, and that is equal to negative, and we have 0.6972243623. There we go. And obviously in the question here it wants our answer to 3 significant figures, so I'm going to chop that after the third significant figure, so 697, chop it there, and we get an answer here of negative 0.697 to 3 significant figures. Now I'm going to do the negative one now, so without changing anything I'm going to write this down here. I'm going to go into my calculator, onto the top line, I'm going to delete the plus sign, put in a takeaway and press equals again, and that gives me a value of negative 4.302775638. There we go. And again we want that to 3 significant figures, so 430, chop it after the 0, and we get an answer there of negative 4.30, and again that 0 has a 2 after it, so that's not going to round up, but we are going to emphasise our answer there with the additional 0. So there we go, there's our two solutions, negative 0.697 and negative 4.30, and they are our two solutions there where this quadratic would cross through the x-axis. Okay, but in terms of this, they are our solutions to this quadratic equation. Okay, so this says, solve the simultaneous equations and give your answer to 3 significant figures. And that is a massive hint there in the question that you're going to be using the quadratic formula, because it means that our answers are going to be some quite nasty decimals. Okay, so we're going to be giving it to 3 significant figures. It just gives you a massive hint that we're not going to be able to factorise this at the end. But let's take exactly the same approach and see what we get. So for this first equation here, I'm going to make it y equals to avoid having to divide by 2. So let's just rearrange that to start with. We'll take away 2x from both sides, and it will say y equals 3 minus 2x. Okay, and let's sub that in for y then. So subbing that into that top equation, we're going to get x squared plus this 3 minus 2x, that's squared, and that equals 20. Now if we expand all this out, we get x squared plus, and you can write out the double bracket here if you like, but 3 times 3 gives us 9. We get minus 2x times 3, which gives us minus 6x, and we've got 2 of those, so minus 12x. And then negative 2x times negative 2x will give us positive 4x squared. There we go, and that equals 20. I'm going to rearrange this, tidy it all up, so the x squared and the 4x squared will equal 5x squared. We've got the minus 12x, and then we've also got, let's have a look, let's write this in, minusing the 20 there, I'm going to do it in one step, so we've got 9, the positive 9, take away 20 gives us negative 11, and that equals 0. Now you can see from that our factor pairs for 11 are only 1 and 11, and if one of them gets times by 5, we've got 5 and 11, or 55 and 1, is it? Let's have a look, is it, yeah, 5 and 11 or 55 and 1. Neither of those pairs are going to make negative 12 in the middle, so we're not going to have the option to factorise here. So we're going to have to use the quadratic formula. So obviously you're going to need to know the quadratic formula for this, so do obviously check out the video on that if you're not sure on it. But we've got a equals 5, the coefficient of x squared. We've got b equals negative 12, the coefficient of x, and c equals negative 11. Okay, so we're going to sub that into the quadratic formula. So obviously always just write the quadratic formula out before you start substituting it in. So let's write it out. We've got x equals minus b plus and minus the square root of b squared minus 4ac, and that's all over 2a. And if we sub these in, we've got quite a lot of steps here, but let's sub those in. So negative b, and that's negative 12, so negative of negative 12 would be positive 12, so we have 12 plus and minus the square root of, a little trick for the quadratic formula, when b is negative, a negative number squared is going to be positive anyway, so I mean you can write it in like this, negative 12 in brackets squared, but I would probably just type in 12 squared, it just avoids making that negative error on the calculator. So obviously just be careful that you do put it in brackets, because if you put negative 12 squared in your calculator you'll get negative 144 and not the positive 144 that we know it is unless you put it in a bracket. So negative 12 squared, take away, and we've got 4 times a, which is 5, times c, which is negative 11. Just extend that, there we go. So that's what I'm going to type into my calculator, and it's all going to be divided by 2a, which is 2 times 5. Okay, again, I'm using the Casio ClassWidth, so I'm just going to type it in. Again, I've put the link for that in my description if you're not sure on these, because it's quite hard on some of the other calculators, but as long as you've got one of these dual level calculators, it's quite nice and easy to type in. Now what I'm going to do is I'm going to type it in twice, once with the plus sign, once with the minus sign. So the first one I'm going to type in, I'm going to do my plus, and I'm going to see what we get for that. Then I'm going to do the minus, and we'll see what we get for that one. Okay, right, so fraction button, I've got 12 plus, let's have a look, square root, in brackets, negative 12, close brackets squared, take away 4 times 5 times negative 11, and then onto the bottom of the fraction, 2 times 5, which is 10, so I'll just type 10 in, equals, and you normally get like a little surd answer or a fractional answer here, so I'm just going to press your S to D button, turn it into a decimal, and for that positive version there, we get 3.10787, and a few more decimals, but it only wants it to 3 significant figures, so don't forget that. So I'm just going to write it down to 3 significant figures. So for the plus version, I get 3, which is my first significant figure, 0.107, so that's 7 rounds the 0 up to a 1, and I get 3.11. Okay, so there we go, there's my first solution. It is always sometimes worth just writing the whole digits down, so if I just write them down, we get x equals 3.107 878,403. There we go. So that's the full answer there, but I've just rounded it to 3 significant figures. So go back into the top of the fraction. I'm going to go all the way back without deleting anything. Delete the plus sign, turn it into a minus sign, and press equals again. So for the negative version there, I get negative 0. And here's my first significant figure now, 7, 0, and it's 7, 8, so the 7 rounds up to an 8, so negative 0.708. If I write down the full one over here, we get negative 0.70787 84028. 84028, if I can fit that in, there we go. Right, so obviously I've just rounded it to my 3 significant figures there. So let's have a look now. Obviously what we've got is 2x values that aren't particularly nice here, they're both horrible decimals, but we are using a calculator, so substituting these values back into our equation isn't going to be too bad. So I'm going to sub it back into this equation here, y equals 3 take away 2x. So I'm just going to get rid of some of the working out here so we can see this. We've got our x values, I'm just going to remove all of this here. Okay, right, so let's have a look. So when x equals 3.11, we've got y equals 3 take away 2 lots of 3.11. There we go. And what I am going to do actually is I'm going to sub in the original values when I do this, and that's why I've written them down in full, just to make sure I don't make any rounding errors here. But in my working out, I'm just going to write there 3.11, so my answer might be different here as if I had have subbed in 3.11, because I am going to sub in these original values just here, okay, which is why I've written them down. So on my calculator, 3 take away 2 times, and let's type that all in, 3.107 878,405, I think it was. Just make sure you write it down clearly so you can read it, and press equals, and I get y equals negative 3.215, so 3.22. There we go, rounding that again to 3 significant figures, although it was negative 3.215. Okay, and that 5 rounds it up. So there's our first solutions. We've got when x is 3.11, y equals negative 3.22. Okay, that's my first set of solutions there. And for my second one here, let's have a look what we get. So our second one there, we had x equals negative 0.708. And again, I'm going to sub in the original number there, but obviously just be careful with that, okay, because I just don't want to get any rounding errors. So if I sub that in, y equals 3, take away 2 lots of negative 0.708. And let's see what we get for y. I'm going to have to type this in again. So I'm going to go back into my calculator. I'm just going to delete that old one. 3 take away 2 times negative 0.7078 784 028 at the end, I think. Doesn't actually matter as we get this far into the decimals. That's not going to have much effect on my answer. But there we go, press equals, and we get y equals 4.415. The 5 rounds it up, so it's 4.42. But again, you can write down all the digits and then round it afterwards. And there is our second solution. Okay, so x equals 3.11 and y equals negative 3.22, and for the other one x equals negative 0.708 and y equals 4.42. Okay, obviously after rounding that to 3 significant figures. So quite a lot going on there. Very similar process. You've got to be quite happy with the previous questions actually to extend it onto these with the quadratic formula. Okay, so we have a slightly different question here because we have some overlapping triangles. So it says in the diagram below that PQ is equal to PR. So we know that this length here is equal to this length here. So therefore, straight away, we know that this is an isosceles triangle. So we'll think about that later. It says S is the midpoint of PQ. So if S is the midpoint of PQ, this line here is the same length as this line here. And that is going to apply on the same side as this length here is the same length as this length here. So again, we'll think about that in just a second. It then says prove that triangle QTR is congruent to triangle RSQ. So Q to T to R is this triangle just here. And overlapping that is the other triangle where we have RSQ, and R to S to Q is just there. So as you can see, they overlap, but hopefully you can see them relatively clearly, and we're going to have a go at proving this one. So to start with, can we see anything that's the same in both? And I think personally the easiest bit to see here is that they both have the same base length. As they both share the same line, that's an easy bit of proof for us to say. So for the first one, I would say QR is the same length in both. There we go, so that's a nice easy one. Same length in both, and that has already proved a side. So we've got our first side proved. Let's think about what else we could prove. Well, another thing that we mentioned was the fact that this line here was the same length as this line here, as it says that that was a midpoint. And we know that because it's an isosceles, if it's a midpoint on both, then both halves must be the same length on either side. So I could also say, and this is a relatively nice one on this one as well, that Q to S is equal to T to R. And we just need to think about how we would give our reason, because both lengths are the same and both are midpoints. Okay, both, or halves I could say, both halves of the same length side. And you could write that in different ways, but I've just tried to write it in an obvious way there. So both halves of the same length of side. And again, that is a side. So we've got two sides already. We just need to think about what else we can find. And again, it goes back to thinking about the fact that it's an isosceles. We know if this is an isosceles, where these two lengths are the same length, we know that in an isosceles, base angles are equal, as we have our isosceles triangle. So for the final one there, I could also say that the angles there are the same as it's an isosceles triangle. So I can say that angle, and what is it, PQR is equal to PRQ. There we go, and those angles are going to be equal. Let's just get rid of that, that doesn't quite go over the R there. There we go, PRQ. So they are equal because base angles in an isosceles are equal. And it's quite awkward having to write it all, but very important that you write it all down. So base angles in an isosceles are equal. So we've got our 3 points there, that was another angle. So just thinking about what we have an angle in between two side lengths. So therefore, triangle QTR is equal to triangle RSQ. And our reason there is because we have an angle in between two sides. So that is going to be SAS. And there we go, that finishes off our question. Okay, so one of these questions then, and it says in London a pint of milk costs 58p and in Paris a litre of milk costs 1.05 euros. So a litre is 1.76 pints and a pound is 1.17 euros, and in which city is the milk better value for money, London or Paris? So let's get everything 1 into the same units and 2 into the same money, okay, and then we'll compare it. But let's have a look at what happens if we do that. Now we've got 1 pint is 58p, so let's leave that as it is. Okay, that's 1 pint equals 58p. I'm just going to write that down here. 1 pint, 58p. Okay, now let's have a look at our next one. We've got 1 litre at the moment is 1.05 euros. So we've got 1 litre, there we are, and we've got 1.05 euros. I'm going to put the little euro symbol in, there we go. Now, it's up to you which one you convert first. We can actually convert the litres into pints, or we could convert the euros into pounds. Now, it says here that 1 litre is 1.76 pints. So as that's the cost of 1 litre, rather than writing it as a litre, I'll just write it as the amount of pints. So that's going to be 1.76 pints. There we are, and this is still the same cost. All we've done is written it in pints instead, so it's €1 and 5. Okay, so we can start writing this down here. We've got 1.76 pints. And I want to put the cost now into pounds or into pence. We'll have a look at what it comes out as. So at the moment, this is my amount of euros. Now again, looking at the exchange rate, we've got an exchange rate over here. £1 is 1.17 euros. So I just want to convert that back. Now, the euros is higher than the pounds, so we know we're going to get a smaller number. So to get this into pounds, I'm going to divide it by the 1.17. There we go. So divide that by 1.17. Let's see what it comes out as. 1.05 divided by 1.17. And on my calculator, that comes out, it's not very nice, 0.897435, and there's a recurring above the 8 and the 5 there. So obviously that is the cost now for 1.76 pints, and we already have the cost of 1 pint as being 58p. So that's our exchange rate done. Okay, all we've done is written the amount of pints that it said there, and obviously converted the euros back into pounds. Okay, that's 89.7435 pence. Now, just like we did on best values, we now just need to have the same amount of both. And if you remember from that, we do the cost and we divide it by the amount, and that's going to get us the cost for 1. Now this one on the left here is already 1, it's 1 pint, but this one on the right, that is not 1 pint, it's 1.76 pints. So we're going to get the cost, which is that 0.8 number there, and we're going to divide it by the amount. So the amount there is 1.76. So we'll divide it by 1.76. I'm just going to do that on the calculator without having to type it all back in again. So leave that on your screen so you don't have to retype those recurring decimals in. So divide by 1.76, and I get the answer, and it comes out as 0.509, and there's a lot more decimals here, 90675. That is in pounds, so if I write that in pence there, it's that bit there which is my pence, so it's 50p.99. I'll just round it there, I'll just leave it like that. Okay, obviously I don't need to make it perfect, because at the end of the day I'm just making a comparison, and I've got enough in my figures there to make that comparison. In fact, I could just say that that's 51p. There we go. To be fair, it doesn't round up. It does to the nearest penny. So actually, let's just do it to the nearest penny. 51p. There you go. But the important thing is it's obviously less than the 58p. So in terms of the best value here, it's better value here, the 51p. That's per pint, and obviously it's 58p here in London. So I would just make the statement, and it's better value in Paris. There you go. Better value in Paris. There we are, and there's our final answer. So just thinking about the steps here before you have a go, obviously the first thing I did was I just wrote them both in the same units. Okay, so obviously we put them both as pints, and that was easy enough because it gave us the cost of 1 litre, and 1 litre is 1.76 pints. So I literally just rewrote it just with the pints figure rather than the litres figure. The next step was obviously just to do an exchange rate conversion. So I changed the exchange rate. I could have put them both in euros if I wanted, but again I decided to put them both in pounds, and then I just took that pound pounds amount and did cost divided by amount in my best value like we did in those earlier questions. So it's putting it all together. There's a lot of language there. They're not the nicest and easiest questions to figure out, but hopefully a little bit of a strategy there to be thinking about how to go about it now. So it says 2 ships leave a lighthouse L, and that lighthouse obviously shown to us on the diagram just here, we've got L. Then it says ship A is on a bearing of 70 degrees from L. Okay, so ship A has obviously gone in this direction over here. There we go, and we've got that 5 kilometre distance there. And then it says, and let's just highlight that, so ship A, and then we've also got ship B, and it's on a bearing of 210 degrees from L, and that's going down here, this 3 kilometres there, down to B. And it says calculate the distance between ship A, and let's just highlight that ship B there with the colour I've just done. It says calculate the distance between ship A and ship B, and give your answer to 3 significant figures. So it wants the length of this line here, A to B. Now thinking about how we could actually find that, because we have got a triangle there in that image. Okay, and what we need in order to find that third length there is we're going to be thinking about using sine or cosine, but actually if we can find one angle, which hopefully you can see is quite a clear one here if you clued upon your cosine rule, if we can find this angle here, we can apply the cosine rule. So that's the angle that we're looking for, and we're going to think about how we could actually get that angle there. So let's get rid of some of this stuff that I've drawn on there. There we go. So it says that this angle here is 70 degrees. Okay, that's given to us in that first piece of information where it says ship A is on a bearing of 70. Then it says ship B is on a bearing of 210. So if I do that in a different colour, that's going right from that north line all the way round to this line here, and it says that that is 210. So the difference between those is going to give us that angle there within the triangle. Okay, the difference between them is going to give us this angle here. If the full angle is 210 and that part of that angle there is 70, then what's going to be the difference between them? Well, let's work that out. It's 210, take away 70. I'm going to do all this on the calculator. This is going to be a calculator topic, so obviously don't rely on it on a calculator question. We should be able to work out that that's 140 really without a calculator. But there we go, we've got 140 degrees within the triangle. Okay, it's obviously just finding the gap between those two angles there. So let's get rid of that and let's stick this angle in there that we're actually going to use. We're going to use 140 degrees. Now once you've got that angle, to be honest, the rest of this question is quite simple, just in the sense that all we really need to do is just apply a bit of cosine rule, and if you're quite clued up on the cosine rule, you're probably already spotting at how simple that question is. Obviously, if you find the cosine rule simple, obviously that is already quite a high level topic as well, but we have got the angle and we're looking for this opposite side, so that'll be our big A, this will be our little a, and these will be B's and C's. Again, don't worry about the fact that they've labelled the corners of the vertices of the triangle with A's and B's. When it comes to using the cosine rule, you label it as you want. So using the cosine rule, and thinking about what that is again, we've got A squared equals B squared plus C squared minus 2BC cos A. There we go. Obviously the variation of it that I'm going to be using. So let's just plug the numbers in, that's all we need to do. So we've got A squared equals, we've got, let's just write this down, B squared is 5, so 5 squared plus 3 squared minus 2 times 5 times 3 cos 140. There we go, we'll put that 140 in a bracket, that's what comes up on the calculator. So let's just type that all in, and that'll give us our value of A squared. So if we type that in, 5 squared plus 3 squared minus 2 times 5 times 3 cos 140. Let's just double check that, make sure you've typed it in okay. So 5 squared plus 3 squared minus 2 times 5 times 3 cos 140, lovely, press equals. There we go, and we get A squared equals 56.981. And a few more decimals. We're not going to write them all down because we obviously want the value of A, so we're going to have to square root that anyway. So to square root that then, let's just write that working out down. We're going to do the square root of that, and we get square root answer 7.548. Let's just write all this in. 7.548. How many decimal places or significant figures does it want it to? Let's have a look in the question. So it gives you your answer to 3 significant figures. So I've written down 4 significant figures at the moment, so that's plenty for my working out. There we go. So all we need to do now is chop that after the third significant figure, which is after the 4, and we get our value here of 7.55. There we go. So let's write that down over here. We've got 7.55, context of the question, it's in kilometres, so 7.55 kilometres. Right, there we go, and let's just highlight that. There we go, as our final answer. So just thinking about how we used a bit of bearings there to find the missing angle, and then we just applied a bit of cosine rule, obviously, to find our missing length there. Okay, so this question says, enlarge shape A by a scale factor of -1/2 from the centre -1, -2. So -1, -2 is here. Now this is, again, we've got a fractional negative enlargement now, so this is obviously a little bit nastier because we're not only going to move in the opposite direction, but we're going to move half of that distance as well. So I probably will write these ones down for this one, but let's pick a corner. So we'll go for this one here. Now going downwards, let's have a look from that centre of enlargement. That's 1, 2 down. So we'll write that down, 2 down, and 1, 2 across, so 2 to the right. Now I'm just going to reverse that just like before. Let's get rid of these lines. So reversing that, that would give us 1 up, because the scale factor is 1/2, so we're going to go 1 up, and instead of going right, we're going left, and again half of that is going to be 1. So not forgetting what a fractional scale factor does there, it's going to halve those distances. So let's go about actually moving that then. So back to the centre of enlargement, I'm going to go 1 left, 1 up, and that puts me just here. Okay, so obviously you're going to have lots of lines when you draw this in, but I'm just going to get rid of them. Right, so on to the next one. Let's pick another corner. So this top one up here, again from the centre of enlargement, how do we get there? Well, we could go 1, 2 to the right. Oh, don't know why I did that. There we go. 1, 2 to the right, and 1, 2, 3, 4 up. So let's have a look. Let's write that down. That was 2 to the right, and that was 4 up. And there we go. And again, all we're going to do is just reverse that and go in the opposite direction. So drawing that in, let's have a look. We're going to halve it, not forgetting. So that's going to be 1 to the left rather than 2 to the right, and it's going to be 2 down rather than 4 up. Okay, just halving those distances. So if we draw that in again from the centre of enlargement, let's have a look. Let's do that in that same colour there. So from the centre of enlargement, 1 left gets me there, and then 1, 2 down. There we go, gets me just there. There we go, and let's get rid of those lines. Now onto the final point again, because I just still don't think it's quite easy just to see exactly where that final point is going to be. You might start to be able to see it in your head, bearing in mind it's going to have that 180 rotation, but let's just go with this last point just here as well. So from the centre of enlargement, that's 1, 2, 3, 4 to the right, and 1, 2 down. So let's write that down. That was 4 to the right, and 2 down, and again we're just going to reverse that movement. So we'll reverse that, and that gives us, halving the 4 gives us 2, so 2 to the left, and halving the 2 gives us 1 up again, obviously in the opposite direction. So that's 1, 2 to the left, and 1 up, and that puts me just there. There we go, let's get rid of these lines, and then we just need to obviously connect all these together, and you'll see it does actually form that triangle there. There we go. I've not drawn that in the best way there, but obviously using a ruler and a pencil and drawing that in, you can see that obviously the triangle is half the size. The base, which is now here upside down, is got a length of 1. It previously had a length of 2 down here, and obviously the height of the triangle, which we can see just here, is a height of 3, and it previously had a height of 6 just there. So it is half the size, but it has also got this negative enlargement going on, which has given it this 180 rotation. Okay, so that's how we do a negative enlargement. Now what we have is a problem here with 2 triangles put together, and it says work out the length of A to D, which is this length just here. Let's label it X. It says give your answer to 3 significant figures, and that's all that we have. So in order to get that, can we use, and obviously when these 2 triangles are put together like this, it's normally a hint that we're not going to be able to get that length straight away. But if we actually have a look at that triangle, we have that length, which is opposite 86, and we've got the 11.4 on that triangle. So we need another bit of information. We'd either need another angle, say this one or this one, which would allow us to use the sine rule because we'd have 2 pairs of opposites, or we would need this length just here, and that would allow us to use the cosine rule, as we would have the 2 adjacent sides to the 86. So I think that's the way we're going to have to go here, because if we look, we should be able to get that missing side from the triangle below. So again, let's have a look and see if we can use the sine rule. Well, we have a side opposite the 109, and the side we're looking for is opposite the 34. So we can definitely use the sine rule. So I'm going to label up the sides now. I like to use A and B only, so I'm going to leave that big B where it is and label this as little b, and I'm going to change this C into a big A, and the side I'm looking for, we'll call that little a. So putting that into that sine rule. So the sine rule is A over sine big A is equal to B over sine big B. So if we put these pieces in straight away, we get A over sine of the opposite angle, so that was 34, and that is equal to B, which we've got labelled as 12.5, over sine of the opposite angle, which is 109. So we have one step to rearrange that to get our answer for that missing side length in the middle of the two triangles. And I can do that by multiplying sine 34 to the other side. Now when we do that, sine 34 will just go up onto the numerator. Of course you could work that side out and then multiply it by sine 34, but I prefer just to stick it on the top next to the 12.5. So we have 12.5 sine 34 all over sine 109. So there we go. If we type that into our calculator, putting our fraction button in and putting everything just like that on the top and the bottom, we get A is equal to, we get quite a long decimal here. Now it says 3 significant figures, so let's give it to at least 7. We have 6 or 7, I'll go for 7. So 7.3926 and then 74, we'll stop there, and that is going to be plenty. Okay, so let's label that on the diagram. So this length here is that 7.39 number. Just going to put that there so it doesn't clog up the diagram too much. Now I can move onto the triangle above. So now, because I have that missing side in the middle of the two triangles, we can think now, can I use the sine or cosine rule? Obviously we've already established that at the start, but let's just quickly see why we can't use the sine rule. We've got one pair of opposites here, we don't have one there, and we don't have one here. So unless I want to try and keep going and potentially try and find another pair of opposites, then I'm going to check the cosine rule. So we're looking for the side opposite 86, so this would be my big A and little a, and I now have the two adjacent sides. So this would be B and this would be C. So I definitely can use the cosine rule. So I'm going to put this into the cosine rule, which is A squared equals, and then we have B squared plus C squared, so 11.4 squared plus the 7.39 number squared. In my working out, I'm just going to put that, but I'm going to use this full number just here. And then it's minus 2bc cos big A. So minus 2 times B, which is 11.4, times the C, which is the 7.39 number. It's going to be awkward to keep typing that in. And then we have cos of the big A, so cos of 86. So that is what I need to type into the calculator. So if we type that all in, we get, we get an answer, but that is going to be an answer for A squared. Now I want to get the answer just for A, so what I'm going to do is I'm going to put it all under the square root. Of course you can type that all in and then press square root answer, and that's probably the way most people are going to prefer to do it. So I'm just going to write that A is going to be equal to the square root of the answer. And when we type that all in, we get 13.147, and then I get 39. Again, a few more decimals, but it did only say it wants my answer to 3 significant figures. So I kept my working to around 7 significant figures, and now I've got an accurate answer here that I can round to make sure that I didn't get any rounding errors along the way. So 131, 1 is the third significant figure. It's a 4 after the 1, so it's not going to round up. So my final answer will be 13.1, and that's in centimetres. So there we go, there's my final answer using the sine rule to start with, and then using the cosine rule on my second triangle. Okay, so find the equation of the tangent to the circle with equation x squared plus y squared equals 5 at the point 1, 2. Now you don't have to have a picture for this, it can sometimes just help just to visualise it, to just draw a little sketch. They're all centred at 0, 0, so we can just draw a little sketch. Doesn't matter if it's any good or not. 1, 2 will be in this quadrant here, and then we can draw part of the tangent there, and we can just label it up. So 1, 2, obviously centre 0, 0. There we go, and we can use that to try and help us visualise this. So we are going to find the gradient of this radius here, which we can do by drawing a little right angled triangle in. So the rise goes from 0 up to 2, and the run goes from 0 to 1. So we can just use that to find our gradient now. So the change in y over the change in x is 2 over 1. There we go, that's quite a nice one because that's just 2. So our perpendicular gradient, doing our negative reciprocal of 2, remembering again that 2 is just 2 over 1, so it becomes 1 over 2, and swapping to a negative. So there's our gradient. And again, from here, it's pretty much the same steps as on the previous video there. So let's just have a look. We've got y equals minus a half x plus c, and then our coordinate is 1, 2. And if we sub that in, let's see what we get. We get 2 equals minus a half times 1, which is just minus a half, so I won't bother writing that in, plus c. Add the half over, we get 2.5 equals c, and that's fine to leave it as a mixed number. And now we can just write our equation, just replacing c with 2.5. So y equals minus a half x plus 2.5, and again you can write these as decimals if you want. You could write minus 0.5x plus 2.5. Okay, likewise you could even write 2.5 as 5 over 2. You can leave it as a top heavy fraction if you want, or improper fraction. Absolutely fine for you to do. As you can see, that one there was a little bit nicer than the last one. Okay, so just showing you that they're not all that nasty. Still obviously a difficult topic, but that's a nicer version of one of these questions. We'll have a look at one more before you have a go. Okay, so find the equation of the tangent to the circle with the equation x squared plus y squared equals 29, but at the point negative 5, 2. So thinking about what this one looks like, okay, just draw a little sketch. And negative 5, 2 is going to be over here in this quadrant. Okay, negative 5, 2. So if I was to draw a little tangent, it'd be sloping this way this time. There we go, so let's label that up. Minus 5, 2. And again, centre 0, 0. And again, let's think about what this would look like. So drawing in our gradient, our radius, sorry, and thinking about what the lengths are this time. Now, obviously, the gradient of the radius this time is going to be negative, look, because the radius is actually sloping downwards. So let's have a look at what we get. So the change in x goes from negative 5 to 0, which is positive 5, and the change in y goes from 2 down to 0, so that's minus 2. There we go, so that's why we're going to get our negative gradient here as well. So the change in y over change in x is negative 2 over 5, which means we can get our perpendicular gradient again. So flipping it over gives us 5 over 2. And again, it turns it from negative to positive. There we go, so not too bad. Now we can put that into our line equation. So y equals 5 over 2x plus c, and then we can go about subbing our coordinate in just like before. Right, so our coordinate this time is negative 5, 2, and if we sub that in, what do we get? We get 2 equals 5 over 2 multiplied by the x coordinate there, which is negative 5, plus c. Expanding that out to tidy it up, 2 equals, don't forget that's negative 5 over 1, so it's minus 25 over 2, plus c. And again, we've got this scenario here where we have an improper fraction. So if we make that into a mixed number, 2 goes into 25 12 times, remainder 1. So that's negative 12.5 or negative 12.5. And we can add that over to 2 nice and easy. And if we add that over to 2 to solve this as for c, we get 14.5 or 14.5 equals c. Right, and now we can put that in place as c up here. Now again, it wouldn't be wrong to do so, but I'm going to keep it consistent with my fractions here. So the 5 over 2 there, I'm going to turn that into a mixed number and keep it all consistent. I could turn it into decimals if you like, but as long as I keep it consistent. But actually it wouldn't be wrong to leave one as improper and one as a mixed number. So y equals 2.5x, 2 into 5 goes twice, remainder 1. So 2.5x or 2.5x plus the 14.5. And again, you wouldn't be wrong to leave one as an improper fraction and one as a mixed number. I just personally don't like it when they are mixed up, but you are absolutely not wrong to do so. Likewise, we could write y equals 2.5x plus 14.5 as a decimal. There we go, so they're the steps. You need to find the gradient of the radius, which remember always goes from 0, 0, so it's actually just the y coordinate over the x coordinate at that intersection. Then do your perpendicular gradient, so your negative reciprocal, put it into y equals mx plus c, sub in your coordinate, solve it for c, and then write the equation of the line. Okay, so lots of steps there, so hopefully you've made some good notes on this. Right, okay, so 3 more here. On the grid, shade the region that satisfies these inequalities. So for the first one, we've got y is less than 3x, or y equals 3x is the one we're going to plot. So that doesn't have a y-intercept, so that y-intercept is going to be 0. I should be careful with my language there. It does have a y-intercept, it's just that it's not a whole number there. We've just got the 0 as the y-intercept. So we're going to start at 0. It's got a gradient of 3. So I'm going to go across 1, up 3, across 1, up 3. I'm going to follow that pattern going backwards, so left 1, down 3, left 1, down 3. There we go, and that's our first line there. Y is equal to 3x, and it's going to be a dotted line. As we've not got the extra ink on the inequality, it's going to be less than 3x. There we go. So let's just draw that in as best you can, obviously using a ruler and a pencil. Now we've got the next one. So y equals 0. That's an interesting one. Y equals 0 is actually the x-axis. It's just another name for the x-axis. So we can go across here. That's the line going through all the points where x equals 0. Sorry, y equals 0. There we go, going across. There's our second inequality. And our last one here, which isn't the nicest, we've got 4x plus 3y equals 12. We need to draw that. Now again, one that looks a bit dodgy, so I'm going to apply that same logic. I'm going to go when x is 0, so we've got 0 plus 3y equals 12, because 4 lots of 0 is 0 there. So 0 plus 3y equals 12. Well, 3 times the number has to equal 12, so y has to equal 4 for that one. There we go. So when x is 0, y is 4. So we just need to find that coordinate. So 0, 4 is there. And the next one, let's do that the other way around. So when y is 0, what's x going to have to be? So we have 4x plus 3 lots of 0, so 0 equals 12. Well, 4 times the number has to equal 12, so that has to equal 3, so x has to be 3 there. So when y is 0, x is 3, and that is there. I'll draw a bit of a bigger cross so we can actually see that. There we go. So we can draw that in, taking that logical approach there. Not the easiest one for me to draw on the screen here, so I'm going to do my best, but obviously you will have a ruler and a pencil, so all you have to do is join those two together and draw a nice straight line. There we go, going through that. Right, there we go. Obviously I've just extended a little bit past the line, past the graph there, but that doesn't really matter. Let's get rid of that. Right, okay, so we've got a basic outline of what it would look like. Obviously yours would be a bit more accurate here when you're using a ruler and a pencil, but that is that last line drawn. Now you could have taken a different approach for that one again. You don't have to take this approach. Just remember, to get that into the form y equals mx plus c, we'd have to take away the 4x from both sides. So we'd have 3y equals negative 4x plus 12. And then we'd have to divide both sides by 3, so we'd end up with y equals negative 4 over 3 divided by 3, x plus 4. There we go. And you could actually plot the graph from there, just remembering what that means. It means there's a y-intercept of 4, which we already have, and then that gradient there just means we've got a rise of 4 and a run of 3. Obviously it's going downwards, so we could go along 3, down 4, along 3, down 4. Obviously just reversing the idea of the gradient there. But again, obviously, if you want to look into these gradient bits a little bit more and understanding these line equations, do check out those videos in the description and look at that coordinate geometry series. That's going to really help with understanding that. But there we go. I quite like just taking the logical approach and imagining one of the coordinates is 0 and finding the other coordinate that matches and then just joining them up with a ruler. It does work for all of these. Right, so let's get rid of all of these. We need to find our region then. So let's have a look. Now we've got a nice little coordinate inside. We've got 1, 1 there. So let's go for that inside the triangle. See if it works. So 1, 1, so x is 1, y is 1. So we've got 1 is less than 3 lots of 1. 1 is less than 3. Again, that's correct. So we can tick that off. The next one, we've got 1 is bigger than 0. Y is 1, sorry. So 1 is bigger than 0. That's correct. And on to the last one. 4 lots of 1 is 4. Plus 3 lots of 1, which is 3. So 4 plus 3 is less than 12. And that's obviously 7 is less than 12. And that's correct as well. So we can tick that off. And there we go. That is our region. Definitely correct there in the middle. Again, this little triangle in the inside. Right, there we go. So that is obviously how to draw inequalities on a graph and how to find the shaded region. Now, as I said, I've linked in the description a link for the worksheet for this these next 4 particular questions. So make sure you've got that either printed off or just follow along with me, or you could even draw it out yourself if you've got squared paper. They're not particularly difficult to draw. I do actually tend to draw these myself anyway, just to get a good understanding of obviously drawing the axes and getting it all plotted to scale, okay, and making sure that you're aware of that. Okay, so for this question here, something slightly different. So obviously do make some notes on this. Again, it's going to be very difficult to draw this particular graph, but in terms of the bits of algebra that we're going to look at in this question, it would be worth writing down the question and worth writing down part A here with our first equation, which we're going to read through, and part B with our second equation. Okay, so writing this down, making some notes on this, because you're going to have a go at this in a sec. So it says here the graph of y equals x squared minus 4x plus 2 is drawn on the grid, and again we can see that, and again we've given that as it's been labelled on the graph there. So if we're going to actually go about this, just obviously read the question, make sure it is all labelled, make sure you know what you're looking at. So for part A here it says use the graph to find estimates to the solution of the equation, and then it says x squared minus 4x plus 2 is equal to 4. So when it says this, this means that two equations have actually essentially been set equal to each other. And if you've done solving quadratic simultaneous equations, which again I'll link in the video, you'll know that when you have two equations, particularly when one's a quadratic and they're both y equals, you can set them equal to each other. So instead of this equaling 0, this time it equals 4. So if we were to split this up into two equations, so for part A here, we could say, okay, well, we've got the graph of y equals x squared minus 4x plus 2, which is matched on the left-hand side, but on the right-hand side there, we have another equation, and that would just be y equals 4. Okay, and this is saying, where does it equal 4? Okay, where obviously if you look at the original equation, y is at the start, and we're kind of saying, where does it equal 4 on the y-axis? So what we mean by that is we actually have to draw this graph of y equals 4. And if we go to y equals 4, which is on the y axis there, we're just going to draw that exact line. So the line y equals 4 is a horizontal line that just passes through every single point where y equals 4. And if we were to draw that in, I'm going to do it with a slightly dotted line to try and get it a bit straighter. Again, because you need to do this with a ruler and a pencil. But there we go, you want to draw a nice straight line across. And from that, we're just going to actually read the coordinates of intersection, where it crosses over, and that's going to be our estimates. So again, you want to read this nice and carefully. You know already that the y coordinates there are 4, so we just want to give the x coordinates here. So the x coordinates, and again, we just want to read those nice and carefully, because we're looking for the solutions to that equation. There we go. So we can go down, read them as carefully as we can, and it looks like on the graph there we have minus 0.5 in the middle, and we have 4.5 just there. So for part A we would say x equals negative 0.5, and the other one x is equal to 4.5. And there would be our solutions to that equation. They are the two numbers that you can substitute into that equation to get the answer 4. Now again, you are just giving estimates, so as obviously you need to draw this as carefully as you can, but it might be that your numbers are just slightly different to mine. Maybe you got minus 0.45, or you're trying to be really accurate with that. So you just need to be very careful, okay? But that is how we're going to go about solving it. Now part B is a little bit more complicated, because if you look at this particular question, it doesn't match on the left and there's nothing on the right. So we're going to have to think about what's actually happened here. Now what's happened is it has been set equal to an equation, but it's been rearranged to make it equal 0. So what I mean by that is it could have been, let's just make it up, x squared minus 4x plus 2. Maybe they set it equal to, I don't know, let's go with 2x plus 3. Now if it was equal to 2x plus 3, this would be the line that we'd have to draw. We'd have to plot the graph of 2x plus 3 and draw it onto our grid. But we don't know what it's equal to. But if it was equal to that, in order for them to make it equal 0, they would minus 2x from both sides and minus 3 from both sides. And if you did that, you would have x squared. If we minus 2x, we'd have minus 6x, which obviously doesn't equal what it is in the question. And if we took away 3, we would have minus 1. And that's how it would equal 0. So I could get rid of this part, and I could imagine that I'd given you that question, and you would have to find out what it is that I've taken away to make it equal 0. So we're going to try and figure out how we can make the left-hand side say x squared minus 4x plus 2 again. So that's the concept of what we have to do here, and this is where it does step up, and obviously this is the hardest type of question, in my opinion, that we're going to be looking at. So let's have a look. Now we want it to say x squared minus 4x plus 2. So what would have to be on the other side? Well, at the moment we've got minus 5x. So to get from minus 4x to minus 5x, we'd have to take away an x from both sides. So instead, let's add an x to both sides. So let's stick an x on the right. And if we were to get rid of that now, it would be minus 5x on the left. So that's the x part done, but we've also noticed there's no number in the equation there that's highlighted. and at the moment we've got a 2. So in order to get rid of that 2, we would have to take away 2 from both sides. So we need to put a 2 on the right, because then if we took away 2 from both sides, the number would disappear. And we can just test this out. So if I take away x from both sides, let's see if it matches what we've got in the question. We would have x squared minus 5x plus 2 equals 2. That's a very bad 2 I was about to draw there. Let's get rid of that. Equals 2. And then for the final step, we take away 2 from both sides. And you probably can already see, hopefully, that we get x squared minus 5x equals 0. The 2's disappear. So that does match what we've got. So we are correct in saying that we need to draw the graph of x plus 2, or y equals x plus 2. So obviously you need to draw the graph of y equals x plus 2. And in order to do that, you need to draw a little table. So again, up to you where you draw it. I'm just going to squeeze it in up here. I'm going to plot some x values, some y values. And let's just go with -1, 0, 1, 2, and 3. So if it's x plus 2, -1 will equal 1, 0 will equal 2, and then we've got a pattern, it's going up in 2s, so 3, 5, 7. And again, you just need to plot that. So let's get rid of all this writing from part A, and let's have a go at just finishing off part B here. There we go. So, drawing this in, -1 was at 1, which is just there, again being very careful of the axes. 0 was at 2, 1 was at 3, and you can probably see a pattern here. It starts to go up. It's across 2 of those squares and up 1. And we can extend that line. Again, you can do it with a ruler, and just be very careful when you join those up. And there we go, perfect. So this one here is actually quite nice because it does actually fall on whole number coordinates. So this one just here gives us x equals 0 and y equals, let's have a look, I can't see the number under there, I think it's 2. Yeah, y equals 2. And for this one just here, we've got x equals, and again just trace your finger down, x equals 5, and y equals, trace your finger across, y equals 7. And there we go, there are 2 solutions. So obviously that one there we were able to give whole numbers. Again, if your line was quite difficult to draw, again you would have to give estimates for that, but this one was quite nice, it gave us whole numbers. So that's how we're going to approach these questions. That is probably one of the most difficult ones that you could probably do, because you actually had to rearrange the equation. The concept behind that is quite tricky, but I've got a question for you to have a go at. So you can have a go at this one. You can pause it, you can rewind it, you can have another look, but here is one for you to have a go at. Now very quickly, before you do have a look at your question, it is worth noting that for this particular question, because those solutions there were whole numbers, you could have actually taken a slightly different approach, but it does say to use the graph. Now for the majority of these questions, they're not going to go through whole numbers, so this was slightly unique, but I thought it was quite nice because it was easy for you to read. But of course, if you did want to find the solutions to that equation, what you could do is factorize it and solve it. Of course, we wouldn't be using the graph, and for questions where we are finding estimates, of course, we wouldn't be able to do that on a non-calculator paper, but potentially, unless we were to give answers in surd form and things like that, and potentially our solution might take a little bit longer to find. Now for this particular one, I know we've given the x and the y coordinate, but in order to find the solution of the equation, or the solutions of the equation, we actually have 2 solutions. Our answer would be x equals 5 and x equals 0. So when we're finding the solution to that equation, we are not finding the solution necessarily to the simultaneous equations, so you just need to be careful of the language. Now it says prove algebraically that 3n plus 1 squared take away 3n minus 1 squared is always a multiple of 12. And that word algebraically is quite key there. We are going to have to use algebra to prove this. So having a look at our expression that we have up here, okay, so I'm going to highlight what we're looking at just now. We are looking at this expression here. If we have a look at that, we can expand both these brackets and tidy it up. And once we've done that, we might be able to have a look and see why it might always be a multiple of 12. So if we have a look at the first bracket to start with, 3n plus 1 squared, that is going to be a double bracket there. So we've got 3n plus 1 multiplied by another 3n plus 1. Okay, so if we tidy all that up and expand that, let's have a go. We've got 3n times 3n, which is 9n squared. And we've got 3n times the 1, which is plus 3n. Underneath, 1 times 3n is another 3n. And then 1 times 1 gives us 1. And if we tidy all that up, these 2 3n's we can add together, and we end up with 9n squared plus 6n plus the 1. Now we can do the same for the other bracket. So if we get that one now, we've got 3n minus 1 squared. So that's 3n minus 1 multiplied by another 3n minus 1. And again, if we expand this, let's see what we get. So 3n times 3n gives us 9n squared again. 3n times negative 1 is negative 3n. Minus 1 times 3n is another negative 3n. And then negative 1 times negative 1 gives us plus 1. And again, if we tidy this up, let's see what we get when we add these two n's together in the middle. We get 9n squared minus 6n plus 1. Now it says in the question just here that we're going to be taking them away, so we're taking them away from each other. So if I stick a takeaway in between them, that is fine, but I've got to be very, very careful here. Okay, and this is where people will tend to make a mistake on this, because it says we're taking away this entire expression. And if we take away everything, really, if I imagine it is in a bracket, I'm taking away all of those pieces from those previous pieces on the left-hand side here. Okay, I'm not just taking away the 9n squared, I'm taking away all these pieces. So if we think about this logically, what we've got 9n squared, take away a 9n squared. So they cancel each other out, they're gone, there's no n squareds left. Then look at the next piece, we've got positive 6n, and we're taking away negative 6n. And if we take away negative 6n, that's going to add it. Okay, so we've got 6n plus 6n. Okay, taking away a negative turns it into a positive there. So 6n add 6n gives us 12n. And then we've got 1 at the end here, take away the positive 1 over here, and that equals 0. They cancel each other out, so 1 take away 1 is 0. So when you've got this takeaway in the middle, you do have to be very careful. It almost changes all the signs in front of those. We've got minus 9n squared, add 6n, take away 1, rather than the symbols there. So we've got our final expression here, we've got 12n. Now it said, prove that algebraically this is always a multiple of 12. Well, if you imagine subbing any number into this now, 12 times anything is always going to give you a multiple of 12. Okay, if you pick any number and sub it in, it's always going to be in the 12 times table. Now when it comes to this algebraic proof, it's always best to just try and factorise at the end. There's pretty much no question that we're going to look at today where you don't have to factorise at the end. Now you could actually make an argument that you don't need to factorise on this one, but if we want to prove something's a multiple of 12, we just have to factorise it by 12. And if I do that, and again this is an optional step on this particular question, but we'd get 12 brackets and just n in the middle. So it's a bit of a weird one to factorise there, but that also proves, look, anything that we substitute into there is always going to get multiplied by 12, and therefore always a multiple of 12, and I'd make that statement down the bottom there. There you go, always multiplied by 12. Okay, and that's going to prove that anything we sub in there is going to be a multiple of 12. Let's have a look at another one. Okay, so prove that the sum of the squares of two consecutive odd numbers is always 2 more than a multiple of 8. Now we have actually looked at this question, but we're being asked to show it in a different way here. We're trying to show that it's 2 more than a multiple of 8. So we've got the sum of the squares of two consecutive odd numbers. So we've got an odd number being 2n plus 1, and we're going to be squaring that and adding it to the next consecutive odd number squared. So that's 2n plus 3 squared. There we go. So that is the sum of the squares of two consecutive odd numbers. If we tidy all this up, and again I'm going to do this one quite quickly, but there you go. We can write it as a double bracket if you like. 2n times 2n is 4n squared. We get plus 2n, which is plus 4n, and then plus 1 at the end. And we're going to be adding that to the other bracket. And if we expand that, we get 4n squared, plus 2 times 3, which is 6n, so 6n plus 6n is 12n, so plus 12n, and then 3 times 3 is 9. Right, so if we tidy all this up, we have the two lots of the 4n squared, which is 8n squared. We've got 4n plus the 12n, which is 16n, and then 1 plus the 9, which gives us 10. There we go. So if we want to finish this off, look, if we have a look at what the question said again, it says it's always 2 more than a multiple of 8. Now if I do factorise this by 8, because it does say multiple of 8, let's see what we get, or where we get to a point where we get stuck. So if we factorise it by 8, 8n squared divided by 8 is n squared. 16n divided by 8 is 2n, that's fine, we can do that. But then 10 doesn't divide by 2 perfectly. But if I did divide it by 8, thinking about back to some maybe some division that we do back when we use remainders, but if we think about what the remainder would be when we divide it by 8, we would get 8 fits in once up to 8, and there's a remainder of 2. And if there's a remainder of 2, I can close the bracket, finish my factorising, and leave my little remainder of 2 at the end there. it's almost like I've split this 10 up into two numbers. It's almost like it says +8, +2, and I've cut it off and I'm just factorising up to the end of that +8. Okay, and after that we're leaving the little 2 there and not factorising that out. So finishing that off, look, it's always going to be a multiple of 8, and then there's always going to be 2 added on at the end. So we've proved that it's always going to be a multiple of 8, but we've got this remainder of 2 which is going to be added on at the end, so it's always going to be 2 more than multiple of 8.
Okay, and that is the end of the video. Well done for making it all the way through with me. I genuinely do wish you the best of luck on your exam. Please make sure that you've checked out the predicted paper and you've also checked out my unseen topics videos to make sure that you've covered absolutely everything on those checklists. Obviously, when it comes to results day, please don't forget to come back and let me know how you've done. I will be eagerly awaiting on results day to find out how you've all done. So there we go, that is the end of this video. I genuinely wish you the best of luck in your exam and hopefully see you for the next one.